Yeah, fine. So what is the, in yesterday's class, what is the last point we discussed? In yesterday's class, what is the last point? Yeah, planar graph, right? So planar graph. Can you help me? Can you help me one small line? I want answer from everyone. I want answer from everyone. Non-planarity will start from where? Non-planarity will start from where? Start. Non-planarity will start from where? That is the last note what I written. Non-planarity will start from, if at all complete graph, Kn where n is 5 or more than 5. If at all complete bipartite graph, Km comma n where m comma n is greater than or equal to 3. Greater than or equal to 3. Everyone know, please careful. So based on that, in one of your previous paper, one question is given. Let's try what answer you are going to give. If G be a non-planar, if G be a non-planar graph with minimum number of edges, then G should have option A 9 edges, 5 vertices, option B 9 edges, 6 vertices, option C 10 edges, 5 vertices, option D 10 edges, 6 vertices. If G be a non-planar graph with minimum number of edges, then G should have. They will clearly verify. Do you know or not? Remember everyone, nothing will happen in single day. Nothing will happen in single day. Something will be happen, right? If you work continuously, if you work 9 more months, continuously work 1 more year, continuously work, you will go to top place. Every day improve. Whatever we are saying, please do it. Whatever we all teachers are saying, please do it. Please do it. If you can do that, trust me, whatever we all teachers are saying, please do it. 1 year continuously do. You will go to top place. 1 year you do continuously, you will go to best place, either IIT or NIT or triple IT, maybe ISRO, maybe DRDO, right? Maybe, I don't know what is written on your fate. I don't know, right? Today onwards, continuously, 1 year you work hard. Don't worry about the result, whether you will get the GATE rank or not, whether you don't get. See, someone didn't get GATE, they got ISRO. Someone didn't get GATE, they got BARC. Someone didn't get, so they got something else. My sincere request from today to until almost 1 year, please keep on improving. No one can stop your growth if you keep on improving. Yeah, can you say what is the answer of this? Everyone know non-planar will start from Kn, where n is greater than or equal to 5. K m comma n, where m comma n greater than or equal to 3. Yeah, right? So he's asking if G is a non-planar graph. I think non-planar will start from this with minimum number of edges. So if you see here, minimum number of edges are complete graph 5 into 4, 20 by 2, so 10. right? So further, if you take right, n value 6, n value 7, they will increase only. But if you take here, I think 3 3s 9, 3 3s 9, 9 edges. So right, I think according to second diagram, minimum 9 edges are there, right, in the non-planar graph. According to first one, minimum 10 edges are there according to non-planar graph. What is the answer? Minimum number of edges. Minimum number of edges. I think this one. What is the answer? 9 edges and 6 vertices. 3 plus 3, 6 vertices. I think B is the answer. Non-planarity will start from Kn or Km comma n, where n is greater than or equal to 5, m comma n greater than or equal to 3. Someone is saying, what about option A, sir? Option A, 5 vertices, how 9 edges here? So K5, right? I think 5 vertices means K5. K5 contain 10 edges. So answer is 9 edges. Wherever 9 there, you select. So these two cannot be the answer. 9 edges is the correct answer. But 2 9s are there. Then how many vertices? I think in the complete bipartite graph, 9 vertices. Sorry, 6 vertices. In the case of the complete graph, 5 vertices. I think 5 is a minimum number of vertices, right? Some people are saying, sir, I will select this one, but he is not asking minimum number of vertices. He is asking minimum number of edges. Then this is minimum number of edges. Then this is the answer. Suppose minimum vertices, then you can go here, but it should be 10. At that time, I think this will be the answer. Suppose if the question is, let G be a non-planar graph with minimum number of vertices. Minimum number of vertices. Then what is the answer? I think option C. Minimum number of vertices. Right? I think minimum number of vertices are 5. Edges are 10. Then C is the answer. Am I right? Suppose this problem, minimum edges, option B, minimum vertices, option C. Will you agree or not? Can you help me? What is the answer of this problem? Minimum number of edges. Let's conclude. Minimum number of edges. Minimum number of edges. Answer B. Minimum number of vertices. Minimum number of vertices. I think minimum number of vertices, right? I think 5 vertices, K5, which contain 10 edges. Option C. Someone is saying, sir, can you please help in power diagram? What is the power diagram? What is power diagram, Bhaiya? Suddenly something came. Power diagram. Sir, can you please help in power diagram? So why you want this? Why you want? So whatever I said, right? So Atul, whatever we covered, please cover all of them one time. Lastly, when you get the idea, right, in one page you can write regular graph, this is the formula, complete graph, this is the formula, right? You no need of any comparisons now. Just read all the things one time, right? What is this? What is that? And so on. Sir, can we say C3 is non-planar? Can we say C3 is non-planar? Of course. Right? See this one. Is it C3? So see everyone now. You know what is the meaning of planar. How can you keep the story of, right, planar graph, and one more thing is bipartite? How can you keep, man? It is a C3. It is already planar. Where is the edge crossing? Where is the edge crossing? You are thinking bipartite graph. Arey bhaiya, bipartite graph and this one, what is the relation? Is there any edge crossing? In the C3, any edge crossing? Is it non-planar? Is it non-planar? It is a planar, right? Array C3R. It is a planar, right? How non-planar? See, where is the edge crossing? Where is edge crossing here? So he is thinking that because of odd length cycle, it is not planar. My man, odd length cycle, it is not bipartite. Odd length cycle, it is not bipartite. Bipartite and this one, no relation. So my request to everyone, please revise the notes and come. My request to everyone, please revise the notes. See, one day I can teach 12 hours also. One day I can teach 12 hours also. If completing is my target, completing syllabus is my target, in 1 month I can complete 3 subjects. In 1 month I can complete 3 subjects. Please, every day, whatever happened, revise and come. Whatever happened, revise and come. Whatever happened, revise and come. This is my sincere request. And one more thing, see this one. If G be a non-planar graph, see, non-planarity will start from incomplete graph, K5 onwards. In the complete bipartite graph, K33 onwards. K33 onwards, right? Careful. Right? Now come to next story. Everyone listen. Come to next story. See this. Arey, where is the Johan? Where is the Johan? Where is the Johan? Atul, please read all of them one time. You read one. Lastly, you can compare. You read all of them one time. Be comfortable with the definitions. Be comfortable with the formulas. Then we will go for comparisons. Let's have the meaning of all the people one time. If I compare also, what you will get, because you are not you people are not comfortable with the definitions also. Please get it first. Please get it. Lastly, in the graph theory ending, maybe there we can talk about some discussion. Right now, come to the next one. Let G be a. Oh. Just wait. Yeah. I'm writing. How many undirected simple graphs possible with n vertices? How many undirected simple graphs possible with n vertices? It is a given problem. Can you check one time? I will give n vertices. How many simple graphs possible? Remember, every simple graph contain n vertices. I am right. If you have doubt, I will write within the bracket. Right? Note, every simple graph should contain n vertices. This is a note. How many undirected simple graphs possible with n vertices within the brackets? Note, every simple graph should contain n vertices. So I think now people are asking, then what is the difference? I think difference is edges or not? Difference is edges or not? How many simple graphs possible with n vertices means every simple graph should contain, right, n vertices. Is asking how many simple graphs possible. I think difference is edges only. Differences is right. Differences are is edges only. From one simple graph to another simple graph, difference is only edges. Yeah, can I give answer? So yeah, I will try mostly writing. If anyone is not okay, I will help you. Everyone observe how many undirected simple graphs possible with n vertices. Remember, every simple graph should contain n vertices. That is a given problem. Now listen this. If you don't listen, you may not get this. If you don't listen, you may not get this. Everyone listen. See this? One by one example I will give. One by one example I will give. See this? See this one? Everyone observe. Everyone observe. Everyone observe. There are two nodes. Careful. N is equal to 2. Two nodes are there, 1, 2. Assume. N is equal to 2. Two nodes are there. They are 1, 2. Okay, I written 1, 2. Can anyone help me with the two nodes? With the two nodes, how many maximum edges possible? With the two nodes, maximum edges, how many possible? First to find out maximum edges, how many possible? With the two nodes, maximum edges, how many possible? Everyone know. Two nodes, maximum edges. Oh, K2. That means number of edges in K2. Complete graph with two vertices. When you say maximum edges, oh, complete graph. So formula is complete graph n into n minus 1 by 2. 2 into 1 by 2. 2 cancel. So one edge possible maximum. Will you agree? When you say maximum edges, oh, complete graph. When you say minimum edges, oh, null graph. Right? When you say maximum edges, oh, complete graph. Minimum edges, oh, null graph. So listen everyone now. With the two vertices, the maximum number of edges possible is one edge. The maximum number of edges possible is one edge. Now listen. Maximum edges possible is one edge. Now listen everyone now. That one edge, maximum number of edges possible is one edge. That one edge may be there. That one edge may not be there. That means there are two diagrams. Can you see the first diagram? That one edge may be there. That one edge may be there. It is a one simple graph. That one edge may not be there. That one edge may not be there. One more simple graph. Totally two simple graphs. Now, if anyone is not getting still, listen, if anyone is not getting still, now you will get the more clarity. Can you see this one? N is equal to 3. Observe here. N is equal to 3, 1, 2, 3. First of all, what you have to do is, with the three people, how many edges possible, find out. With the three people, maximum edges possible. In the simple graph with three vertices, maximum edges possible, count first. Maximum edges possible is three people, 3 into 2 by 2. 2 cancel. So 3 edges, maximum 3 edges. Some people are asking, maximum 3 edges you are saying, right? So what? So what? Let's see this one. Edge 1, edge 2, edge 3, maximum 3 edges. All 3 edges are not there. Right? Next one, right? I think first edge not there, but second edge also not there. Third one may be there. I think all Boolean possibility 0, 0, 0, 1, 1, 0, 1, 1. In all of them, first edge not there. Similar way, right? First edge may be there. 0, 0, 0, 1, 1, 0, 1, 1. Totally 8 possibilities. Some people are asking, sir, can you say that? Can you show that diagram? See the diagram? I will show the diagrams also. Can you see this one? Totally 3 people. Okay. Right. So I think 3 edges, edge 1, edge 2, edge 3. No edge available. All 3 edges are missing. That is the first possibility. Now see the second possibility. 1, 2, 3. See the second possibility. 1, 2, 3. One edge there. 1, 2, 3. 1, 2, 3. One more edge there. 1, 2, 3. 1, 2, 3. One more edge there. Now, if you see I think this possibility completed. 1, 1, 1, 1 concept. Sorry for this one. 1, 1 concept. Where 1, 1? Right? I think one more 1 is going to be this. Only third edge, only second edge, only first edge. Now, 2 edges concentrate. Concentrate 2 edges. Concentrate 2. This is one possibility. 1, 2, 3. 1, 2, 3. This is one more possibility. 1, 2, 3. 1, 2, 3. This is one more possibility. Yeah, I think if you observe clearly, who are those two people? This is 2. This is 2. This is also 2. Lastly, all are there. Lastly, all are there. This is the last one. Yeah, can you guess totally how many? Can you guess totally how many? I think with the 3 people, with the 3 edges, totally 8 possibilities, 2 cube. Because for every edge, 2 choices. For every edge, 2 choices, maybe, may not. 2 cube. Because of you are little bit comfortable, can you see the last attack? Can you see the last attack? N is equal to 4. 1, 2, 3, 4. How many maximum simple graphs possible? First to find out. Maximum edges, how many find out? Maximum edges are 4 into 3 by 2. 2 cancel. It became 6 edges. Maximum 6 edges. Then how many simple graphs possible? 2 power 6 simple graphs possible. This is the answer for this. Now, because of you are little bit okay, can you see the final answer? With the N, listen everyone now. Can you see the final answer? Can you see the final answer? Can you see the final answer? With N nodes, with N nodes, right? Maximum edges possible. Maximum edges possible. N into N minus 1 by 2. Next one, maximum simple graphs possible. Maximum simple graphs possible. Every edge having 2 choices. N into N minus 1 by 2. This is the final answer. Yeah, are you comfortable? Are you comfortable? Are you comfortable? So no need to by heart, no need to by heart. Learn properly. Learn properly. One thing also you cannot learn in the by hearting manner. One thing also you cannot learn in the by hearting manner. Learn properly. Learn properly. Okay. How many undirected simple graphs possible with n vertices? Not every simple graph should contain n vertices. Right? Let's check one by one. First to find out. I think, do you believe or not? Do you believe or not? Am I using the formula of complete graph? Am I using formula of complete graph? If you want maximum simple graph, you need maximum edges. Am I right? If you want maximum simple graph, you need maximum edges. Maximum edges means complete graph formula. 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 Please remember. And one more. When you are using complete graph formula, I think you are using maximum degree also. What is this? 3, 4 vertices are there, right? Maximum degree possible for any person. 3. What I want to say is, if you want maximum simple graph, you need maximum edges. If you want maximum edges, you need maximum degree. It is a maximum degree. So I find out first of all maximum degree. I find out first of all maximum edges. Lastly, I find out maximum simple graph. Everywhere maximum there. See, maximum degree, maximum edges, maximum simple graph. Fine? Fine? Bhaiya, fine? Where is the Priyoshi? Priyoshi, are you there? Priyoshi, are you there? Yeah, there. Ashwini, are you there? Ashwini, are you there? No, no. Abhi, are you there? No. Johan, are you there? No. 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 Yeah, Abhi there. I think, see, this Abhi person, present sir. I think he is having one sticker, present sir. Every time he will type similar way. Type proper, one time present sir. Are you AI? Are you robo? Are you a machine? Every time same present sir. I am observing. Sir, can you one time show the previous page? Okay. This is the previous page. Are you robo? Are you using machine learning AI tools? Someone saying move on to next question, sir. See over what someone saying, sir, can you go to the previous slide, sir? How can you talk here? She is asking about first question. Okay. This is the first question. See, after everything is over, total Ramayana is over. He is asking what is the relation between Rama and Sita. Total Ramayana is over. Total Ramayana over. Total Ramayana over. He is asking what is the relation between Rama and Sita. Can you explain? Can you please one time explain the formula again? Which formula? Last one. This one. This much nicely I explained. This much nicely I explained. Abhi, how can you do, yeah? This much nicely I explained. So 2 vertices. See this one, 2 vertices. First of all, if you want to find out maximum simple graph, 2 vertices. First of all, find out maximum edges how many. With 2 vertices, maximum edges possible. How many? I think 2 vertices maximum means, I think 2 vertex complete graph. What is the formula? Complete graph number of edges, n into n minus 1 by 2. Number of edges in the complete graph, n into n minus 2 into 1 by 2. 2 cancel 1. So with the 2 vertices, maximum edges possible is 1 edge. Now, all possibilities you want. So what is the answer? That 1 edge may be there in your diagram. So one graph you will get, may not be there also that edge, one more graph. So totally with the two vertices, two simple graphs possible. Come to the third one. Can come to the next one. N is equal to three vertices. Maximum edges possible how many? I think K3 number of edges. 3 into 2 by 2. So 3 edges. Now 3 edges are there. Every edge may be there, may not be there. So with the 3 edges, the possibility is 000 to 111. I written the diagram also. 000 to 111. I written the diagram also. Array, Atul, I will beat you. I am saying, don't type big paragraph, yeah. I thought that user was AI. Array, this much big paragraph. You are a content writer or what? Are you content writer? Are you a influencer? Are you influencer? Array, this much content, yeah. System programmer. Array, this much clearly you will type. This much clearly you type. Now let's come here. N is equal to 3. Maximum simple graphs how many? First question. N is equal to 3. Maximum simple graphs how many? First question. Maximum edges how many? Find out. 3. Every edge 2 possibilities. Right? That edge may be there, may not be there. So 2 power 3 simple graphs. Totally 8 simple graph. I written also 1, 2, 3, 4, 5, 6, 7, 8. 8 simple graphs. Now, can you go to N is equal to 4? Maximum edges 6 edges. Every edge having 2 choices, 2 power 6 simple graphs. N nodes, maximum edges, this one. Next one, maximum simple graph, 2 power this, because every edge having 2 choices. That's it. That's it. Abhi, you got it. Abhi, you got it. Right, fine. Let's move to next one. Let's move to next one. Yeah. Everyone observe. Everyone observe. Everyone observe. Is it graph? See the next story. Is it graph? Yes, it is a graph. It is the graph. Everyone be careful. It is the graph. Right? This is the graph. Can you help me know? Graph contains cycle. Graph can contain cycle or not? Graph may contain cycle. Graph may contain, may not contain. Graph may contain cycle. Right? Everyone. And one more. Graph may contain cycle. I am fine. Can you help me know? Graph may be disconnected. Graph may be disconnected. Yeah, graph may contain cycle. Graph may be connected or graph may be disconnected. Anything can happen. So remember, graph is a superset. Anything is a graph. In my opinion, anything is a graph. It may be connected. It may not be connected. It may be having cycle. It may not having cycle. It may be having direction. It may not having direction. Right? Something like that. So this is also a graph. This is a disconnected graph. It may be having cycle, may not having cycle. Everything is fine. Now listen. Now listen, everyone. Now listen, everyone. Everyone listen. If this graph contain, you only observe, you only say, if this graph contain 5 vertices, what are the maximum edges possible? Graph contain 5 vertices. What are the maximum edges possible? Maximum. This graph contain 5 vertices. Maximum edges possible 5 into 4 by 2. 20 by 2. Maximum 10 edges. Minimum edges? Minimum edges 0. Am I right? 0 to 10. Anything can happen. If the simple graph contains 5 vertices, the number of edges are 0 to 10. Anything possible. Sometimes 0, sometimes 10. Sometimes is right, sometimes is in between. Anything is possible. Right? Anything is possible. Anything is possible. So be careful. Now I want to say one small story. Listen, A, B, C, D, E. Everyone observe, right? A, B, C, D, E. Can you help? Is it subgraph? Is it subgraph? For the given graph, is it subgraph? For the given graph, is it subgraph? Yeah, it is a subgraph. Not only subgraph, is it connected? First of all, it is a subgraph. Okay, is it connected? Is it connected? It is a connected also. First of all, it is a subgraph and connected also. Any cycle? Any cycle? No, no, right? So that is the reason. So remember, it is a graph. Graph may contain cycle, but it is a tree. Tree don't have cycle. Here cycle may be there. Here cycle may be there. May not be there. But in the case of the tree, cycle not at all exist. Next one. Graph may be connected, may not be connected. Graph may be connected. Graph may be connected, may not be connected. Maybe, may not. But it is always, right? It is always connected. And one more. See this one more. Graph, right? If at all, because of it is a 5 vertex graph, maximum edges are 10. 5 vertex graph, maximum edges are 10, minimum edges are 0. It is a graph, maximum edges are 10, minimum edges are 0. But because of it is a tree, always connected. There is no maximum, there is no minimum. 5 vertices are there, 4 edges. Because if I keep one more edge, cycle will come, right? 4 edges always. Because 5 vertex tree always contain 4 edges. If I add one more edge, cycle will come. If I delete one edge, disconnected will come. Remember. So 5 vertex tree contain 4 edges and no cycle and connected. Please be careful. So every tree is a graph, but every graph need not be a tree. I'm repeating once again. Every tree is a graph, but every graph need not be a tree. See, if you want, you can check. It is a graph, but it is not a tree. It is a tree and it is a graph also. If anyone asks what are the differences between tree and a graph, you can say like this. Every tree is a graph, but every graph need not be a tree. Next one. Graph may contain cycle, may not contain cycle, but tree, no cycle. Graph may be connected, may not be connected, but tree always connected. Graph, right? If at all graph contain 5 vertices, minimum edges are 0, maximum is 10. But if the tree contain 5 vertices, maximum, minimum edges are 4 only. Cannot be more than 4. If at all more than 4, cycle. Cannot be less than 4 also. Less than 4, disconnected. Are you comfortable what I am talking? Are you comfortable what I am talking? Every tree is a graph. That is the first point. Tree always connected. Second point. Tree don't have cycle. Third point. If the tree contain 5 vertices, tree always contain 4 edges. There is no minimum edges. There is no maximum edges. 5 vertices are there in the tree, right? Always 4 edges. Not less than 4, not more than 4. Right? But in the case of the graph, there are many variations. Right? If at all 5 vertices, minimum edges 0, maximum 10. What is the meaning? 0 possible, 0 edges possible, 1 edge possible, 2 edge possible, 3 edge possible, and so on. And so on until 10. But here 5 vertices are there, always 4 edges. It may, right? Graph may be connected, may not be connected. Tree always connected. Graph may contain cycle, may not contain cycle. Tree never contains cycle. Tree never contains cycle. Please careful. Right? You have to write properly. Now look like everything okay. After some time, problem will come. After some time, problem will come. I am writing only for namesake. Tree. First point maybe. What is the answer? It is a graph. Every tree is a graph. When someone say it is a tree, can you help me now? Tree implies graph, right or wrong? Tree implies graph, right or wrong? If tree, it is a graph also. If tree, graph also. You never know the combination. Tree satisfied, graph not satisfied. It never be. Tree means graph also. And one more. When you say tree, connected also. When you say tree, no cycle. When you say tree, v minus 1 edges. Tree means automatically all will come. Tree, oh, it is a graph also. Tree, it is a connected also. Tree, no cycle. Tree, v minus 1 edges. There is no maximum edges, there is no minimum edges. So, Bhaiya, are you comfortable? Are you comfortable? Yeah, fine. Fine. Now listen. Now listen. Because of your little bit okay, I'm talking few lines, right? So please take care. Please take care. Now listen. Everyone have to listen. Everyone have to listen. Careful. Careful. Everyone listen. Is it tree? Is it tree? Is it tree? Check all the properties. Disconnected? No. So connected only. Cycle? No. 5 people, 4 edges. Is it tree? Is it tree? Yeah, fine. It is a tree. Everyone know it is a tree. Next one. One more thing I want to ask you. It is a tree, fine. It is a tree, fine. Listen, in this tree, if you want, I will give numbers also. A, B, C, D. A, B, C, D, E. A, B, C, D, E. Right? Be careful. So this is the tree. Right? Everyone is okay. A is having how much degree? A is having how much degree? 2 degree. Yeah. B 2 degree. Yes. C is having how much degree? 2. D having how much degree? D having how much degree? D 1. E 1. Yeah, remember everyone. It is a tree, fine. It is a tree, fine. And one more. Is it directed or undirected? Is it directed or undirected? Undirected. It is a tree. Everyone know it is a tree. It is undirected. Remember, in the undirected graph, listen, in the undirected graph, sorry, in a tree, which is the undirected graph, see this one. It is a tree, but undirected graph. Remember, in the undirected graph, which is a tree, a node is said to be a leaf node if it is having degree 1. Right? Remember everyone. A tree, which is the undirected, a node is said to be a leaf node. It is having degree 1. If it is having degree 1, remember. Right? So let me write now. A tree which is undirected. Tree, first of all, it is a tree and undirected. Right? So a node is said to be a leaf node, undirected. A node is said to be a leaf node. Degree 1 leaf node. Remember this also. It is a tree first of all, and one more is undirected. So then if any person having degree 1, it is a leaf node. Degree 1 means leaf node. Some people are asking, sir, can't degree 0 possible? Can anyone help? Degree 0 possible. If degree 0, is it connected or disconnected? Then disconnected. If anyone say degree 0, then disconnected, remember. Remember, it is a disconnected. Right? So a tree which is the undirected, degree 1 means leaf node. Other than degree 1, it is going to be non-leaf. Right? Other than degree 1, which is going to be a non-leaf. Some people are saying that degree 0, then leaf node. If degree 0, undirected graph. Degree 0, undirected graph. If it is undirected, how tree are? If it is undirected, how tree? Right? Fine. I think you got the idea. Now come here. One more thing. A, B, C, A, B, C, maybe D, maybe E. Something, let me write. Yeah. So listen everyone now. It is also a tree. But it is a directed tree. It is a tree but directed. Can anyone help? Whenever it is a directed graph, careful, whenever it is a directed graph, degree there or in degree out degree there. Whenever it is a directed graph, degree there or in degree out degree. Directed graph, in degree out degree. Remember. Listen everyone now. Any person out degree 0. Any person out degree 0, that is a leaf node. Out degree 0. Right? A tree which is the directed one, out degree 0, that means leaf node. Right? Tree may be directed, tree may be undirected. What is the tree rule? Tree rules are very simple. First rule of the tree, it should be a graph. Every tree is a graph. Okay. Second rule, it should be connected. Third one, no cycle. Next one, V minus 1 edges. That's it. If at all directions are there, right? Directed tree. Directions not there, undirected tree. But when you say undirected tree, which is the leaf node? Degree 1. Directed tree, which is the leaf node? Right? Out degree 0. No one going outside. That is out degree. Out degree 0 means, right? Out degree 0, leaf node. So leaf nodes are having two definitions. A node is said to be a leaf node in the directed graph if out degree 0. A node is said to be a leaf node in the undirected graph, degree 1. Anyone having any doubt? Check if anyone having any doubt. Fine. Bhaiya, fine. Anyone having any doubt? Small doubt also there, let me know. Okay, fine, perfect. Now see the answer. So let us assume that directions also there. Assume directions also there. Now talk. Everyone observe. Now talk. Now talk. Okay, to get the clarity, I am giving the labels also. Yeah, labels also given. Can you say, is it tree? Check one by one. Is it tree? Yeah, fine, tree. And one more. Is it directed or undirected? Tree can be directed, tree can be undirected also. When you say it is undirected, you talk about degree. When you say directed, you talk about in degree, out degree. Nothing there. Other than this, nothing. So it is a directed. Can you help me now? It is a tree and it is a directed. And one more thing. How many vertices? If it is a directed, I will talk in degree, out degree. If it is undirected, I will talk degree. Can you count how many vertices? 1, 2, 3, 7 plus 3, 10. 10 vertices. 10 vertices. Can you help me now? Vertex A having how much out degree? Vertex A is having how much out degree? Out degree. Out degree 2. That means, listen, that means A having 2 children. That means A having 2 children. How much out degree? How much out degree? How much out degree? Be careful. How much out degree? Those many children's. So if at all direction not there, how I know how many coming, how many going? How I know? If directions not there, who is coming, who is going? How I know? When he is talking about children, remember, right? A having 2 children means 2 out degree. B having, listen, B having 2 children means B having 2 children means B out degree 2. E having 1 child means 1 out degree. So like that, everyone out degree. Now listen, if you observe clearly this diagram, observe this diagram clearly. If you observe, he is having degree 2. Right? He is having degree 2. Right? So which is also called children's. He is having 2 children's. Right? A is having 2 children. B is having 2 children. C is having 2 children. E is having 0 child. E is having 1 child. E is having 1 child. E is having 1 child. E is having 0. A node which is having out degree 0, leaf node. A node which is having out degree 0, leaf node. Out degree other than 0, internal nodes. Now everyone listen. Everyone have to listen. Careful, everyone have to listen. Total nodes is equal to, careful, total nodes is equal to, please give answer. Total nodes is equal to, I am expecting answer. Total nodes is equal to, can you help me now? 2 children, how many? Total nodes is equal to 2 children, how many? How many people with 2 child? Give answer to me. How many people with 2 child? 3. Right? So 2 child, 3 people. Can you help me? How many people with 1 child? How many people with 1 child? 3. So how much it is? 2 into 3, 6, plus 3, plus 1 also add. Lastly, extra add 1. Total nodes is equal to, right? Whenever it is a binary tree, 2 children are there. So 2 children, how many count? 2 into that much. Next one. 1 child, how many count? 1 into that much. Plus 1 for root. For root purpose, maybe plus 1. If you see total node scale. This is the formula. total nodes in the tree is equal to, right, every person having how many, right? So right, I think 2 children how many, 3 children how many, 4 children how many, and so on count. If at all binary tree, maximum 2 only, 2 children only. If it is n array tree, n children also there. Now some people are asking, sir, how can you say it is a binary tree? No one having more than 2 children. No one having more than 2 children. So binary tree. No one having more than 2 children. See, everyone having maximum 2 children. So it is a binary tree. When you say a binary tree, every person having either 2 child or 1 child or 0 child. 2 child how many? 3 people. 1 child how many? 3 people. Plus 1 also add. Total, it will give total number of nodes. Okay, are you okay? Are you okay? This is the formula, remember. This is the formula, remember. This is the formula, remember. Now I'm going to do one small story. Can you listen? I'm going to do one small story. Can everyone listen? Everyone listen. In a tree, see this one. In a tree, if you want, you can say binary tree. In a binary tree, observe properly. In a binary tree, right? Some numbers, some labels I have to give, I am giving. I1 nodes having 2 children. I2 nodes having 1 child. In a binary tree, I1 nodes having 2 children, I2 nodes having 1 child. Can you help me now? What is the total nodes formula? Total nodes is equal to, what is the answer? I1 into 2 plus I2 into 1 plus 1. Am I right? In a binary tree, I1 nodes are having 2 children, I2 nodes are having 1 child, then total nodes is equal to I1 into 2 plus I2 into 1 plus 1. Am I right? So now some people are asking, what is total nodes first of all, sir? Sir, total nodes formula is this one, it's okay. But what is the total nodes, sir? See this one, total nodes. Everyone listen, total nodes. Total nodes. I1 nodes are right? 2 children. I2 nodes are having 1 child plus L nodes are leaf nodes. Total nodes I1 plus I2 plus L is equal to 2 into I1 plus I2 plus 1. Calculate properly. Calculate properly. I think this I2 cancel. This 2I1, it is simply I1. Send this I1 that side. Then leaf nodes is equal to 2I1 minus I1. So it became I1 plus 1. This is the formula. This is the formula. L is equal to I1 plus 1. What is the I1? The number of people who are having degree 2. Sorry, children's 2. Number of leaf nodes is equal to number of nodes which are having 2 children plus 1. If anyone not getting what exactly I done, can you see this diagram? If you are not getting what I mentioned, can you see this diagram? In this diagram, leaf nodes how many? In this diagram, leaf nodes how many? 4. Which is equal to, can you help me now? Degree 2, children are 2. Children are 2. Can you help me now? Number of children 2. How many? I1 people are having 2 children. I1 nodes are having 2 children. I1 what? 3? I think 3 plus 1. 4. This is also 4. Can you remember this formula? Leaf nodes is equal to number of nodes with the 2 children plus 1. Can you remember this? Can you remember this? Can you remember this? I1 nodes are having 2 children, I2 nodes are having 1 child, then total nodes is equal to I1 into 2 plus I2 into 1 plus 1. First of all, what are the total nodes? I1 plus I2 plus leaf nodes. So finally, leaf nodes is equal to I1 plus 1. Can you remember from today onwards, if anyone asks you, from today onwards, can you give answer directly? Let me check, will you give answer or not? Let me check, will you give answer or not? I am expecting answer. I am expecting answer. Please give answer. I am expecting answer. In binary tree, listen, in binary tree, 50 nodes are there with 2 children. Then leaf nodes, how many? In binary tree, 50 nodes with 2 children. Then leaf nodes, how many? What is the answer? 51. Answer is 51. If you want, you can check. See this one. Degree, listen everyone, number of children 2. One person with 2 children. I think 2 leaf node. Next one. One more person with 2 children. I think what is the answer? 2 children, 2 people. Leaf nodes are 3. Right? So some people are asking, sir, what about this, sir? Listen, some people are asking, what about one child, sir? One child person cannot increase leaf nodes, cannot decrease leaf nodes. See, one child coming, same only there. One child is coming, same only there. Right? Leaf nodes cannot affect. With one child, leaf nodes cannot affect. With the two children, leaf nodes will affect. Now, if you want, you can check, right? How many people with 2 children? How many people with the 2 children? I think 2. Leaf nodes are 3. Leaf nodes are 3. Some people are asking, sir, can I keep one more? I think with the 2 children, 3 people are there. Leaf nodes are 4. In binary tree with 50 nodes, in binary tree 50 nodes with 2 children. Then leaf nodes how many? 51. Can you take care of this? So in this problem, 2 children, how many? 3 people. 3 people with 2 children. So leaf nodes are 4 leaf nodes. Some people are asking, sir, how you got this, sir? How you got? I given proof also. Check. Let us assume in a binary tree, I1 nodes are having 2 children. I2 nodes are having 1 child. Then total nodes formula, using this formula, total nodes formula is equal to I1 into 2 children, I2 into 1 child plus 1. First of all, what are the total nodes? I1 nodes, I2 nodes, and leaf nodes also there. These 3 is equal to this one. Finally, leaf nodes is equal to, right? Leaf nodes is equal to how many nodes are having 2 children plus 1. This is the formula which you have to remember. I derived also. Can anyone having any doubt? Yeah, leaf nodes will not increase, leaf nodes will not decrease because of right, number of children are 1. It don't increase, it don't increase, it don't decrease. Only 2 children will decide the story. Only 2 children will decide the story. Yeah, fine. Fine now. Now listen, because of your little bit okay, can you listen this also? Can you listen this also? See this. K-array tree. Can anyone guess? Listen, he will give in the examination, they will give definition. Don't worry. I am giving definition. Accordingly, I am following. Please observe. K-array tree. In the examination, they will give definition. Now I am giving my definition, what I am thinking. In exam, they will give definition. Normally, what is the meaning of K-array tree? If anyone knows, what is the binary tree? What is the meaning of binary tree normally? Normally, what is binary tree? Every person should contain maximum 2 children or not? Every person should contain maximum 2 children or not? When you say binary tree, every person should contain maximum 2 children, right? Maximum 2 children, 0 to k. Every person should contain maximum k, 2 children. 2 also okay, 1 also okay, 0 also okay. But see this one, listen. So that is the normal binary tree definition. Sometimes they will give definition like this. Listen, k array tree. That means every node. Listen, every node contain exactly. Listen, sometimes he will give definition like this one. Every node contain exactly k children are 0 child, right? K children are 0 child, k child are 0 child, right? See, so remember, in the given tree every node contain exactly k or 0. There is no in between. It is something like full binary tree. Full binary tree means, right, strict binary tree. I think we discussed in algorithm, in data structure subject, we discussed every person contain 0 child or 2 child. That is called strict binary tree. Sometimes he will say similar story like this. If he change the definition, see, he can change whatever way he want. If you don't say anything, k array tree means, remember, if you don't say anything, k array tree means maximum k children. K also, k minus 1 also, k minus 2 also, and so on, 0. But sometimes you will say definition like this. How? K array tree means every node contain exactly k child or 0 child. Sometimes you will say like this. K children are 0 child, right? That is the k array tree definition. Now observe. Now observe what I am going to say. Listen, everyone. Listen correctly. Listen correctly. Yeah. Let us assume that k value 3. Can you help me now? Every person contain 3 children. Every person contain 3 children or 0 child. Will you agree? Children's means out degree, nothing there. At anywhere, if you see child, remember out degree. Can you help me now? K value 3. Every person contain 3 child or 0 child. Will you agree? Every person contain, right? 3 child or 0 child. Will you agree? Someone is saying, sir, is k array strict? Yeah, you see, I think previously you have to understand. If he want to give new definition, he will give, let us assume he given the definition like this. K array tree means this is the definition. See, whenever I am giving my problem, see, my problem I can define whatever way I like. Let us assume k array tree means this is the meaning. Actually, it is the strict one. But he is given like that. Whenever he is giving, whatever way he will give, you take. Whatever way he will give, you take. Right? So I think this is the definition assume. Every node contain exactly k child or 0 child. Let us assume that k value 3. Is it 3 array tree? Can you help me? Is it k array tree? Yeah, if anyone having any doubt, I will clarify. Can you see this one? Is it k array tree? K value 3. Is it k array tree according to the given definition? According to given definition, is it k array tree? Don't confuse. Nothing there to confuse here. According to that given definition, is it k array tree? See, everyone contain either 3 people or 0 people. There is no one having 1 child. There is no one having 2 child. Everyone having either 3 or 0. Now see the answer. According to the previous story, can you see the previous story? Can you see the previous story? Total nodes is equal to, you know very well, total nodes is equal to, listen, total nodes is equal to, observe clearly, total nodes is equal to, right? See the answer. How many nodes are having 3 children? Can you count? How many nodes are having How many nodes are having 3 children? 1, 2, 3. Is it 3? How many nodes are having 3 children? Is it 3? Let's take one more. Otherwise, you may misunderstood. You may misunderstood. Let me take one more. Can you help me now? How many people are having 3 children? How many people are having 3 children? I think 4 people. 1, 2, 3, 4. Now see the answer. 4 people are there, right, with 3 children. And one more, remaining all are 0. 0 no need to write. 0 into anything becomes 0. So 4 people are there with the 3 children plus 1. As usual, see above formula only. In the normal binary tree, listen, in the normal binary tree, 2 children are there. One child also there, right? For the 0 or right root whatever maybe plus 1 extra. In the normal binary tree, 2 child also there, 1 child also there plus 1. But in the case of k array trees, what is the answer? 4 people with k children. Remaining all are 0. No need to write plus 1. Which will goes to, listen, which will goes to 4 into 3, 12 plus 1 plus 1, 13. Can you check how many nodes total? Can you count how many nodes, right, total? I will count. I will count one time. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the formula. Total nodes is equal to 4 people with 3 children. Remaining all 0, no need to write. Plus 1. But in the normal binary tree, 2 children also you have to write. 1 child also you have to write. Plus 1. Now come here. Listen, now come here. Total nodes is equal to, this is the formula everyone know. Please listen. How many people are having k children? How many people are having 3 children? 4 people. So let me write. They are called internal nodes. This is the internal node. The number of people who are having 3 children, their internal nodes. So internal node I1. Let us assume that it is I. Internal nodes are I. Right? So internal nodes plus remaining is leaf nodes. Internal nodes plus leaf nodes means total nodes is equal to this much. Then leaf nodes is equal to this 13 minus I. So this 13, right, minus what is the I value? Which is going to be 9. I am not done anything. If anyone having small doubt, same story I repeated. Whatever I done here, same thing I repeated. So this is the one of the very, very important one. Please take care. So whatever procedure I said, it will work for strict binary tree also. It will work for normal binary tree also. It will work for k array tree also. Anything it will work. Just follow the procedure whatever we done. This is the important one. A major one is this one. This one please take care. From this only everything came. Anyone is getting any doubt, take care. In the case of the k array tree, where every person having k are 0, same story I done. The only thing is 1 child not there, 2 child not there, k child is there, remaining is normal. Yeah. Now anyone having any doubt, you can ask me. Right? So he will ask in the examination whatever way he like. Just apply same story. Yeah. Now I'm asking one question, give answer. Same story, whatever you understood. Whatever you understood till now, same thing, one formula coming. Can you see this? Same thing, one formula is coming. Can you see this one? Listen, in K array tree, I want same thing formula. See, in K array tree, every node, in K array tree, every node contain, in K array tree, every node contain K child or 0 child. In K array tree, every node contain K child or 0 child, and number of internal nodes are, and the number of internal nodes, not leaf nodes. Number of internal nodes are I. Number of internal nodes are I. Leaf nodes are L. Then find L. This is the given problem. In K array tree, every node contain K child or 0 child, and number of internal nodes are assume I. Leaf nodes are assume L. Then find L value. Right now, whatever you knows I am doing. Whatever you knows exactly I am doing same. Exactly same. O per 1 I am repeating. O per 1 I am repeating. Can you see this one? Exactly same thing I am repeating. O per 1 I am repeating. Can you see this? Those people who are typing, please stop typing and listen. In K array tree, every node contain K child or 0 child. Number of internal nodes are assume I. Number of leaf nodes are assume L. Then find L value. Now see the answer. As you know, there is a formula. See this one. Total nodes is equal to, give the answer to me. Total nodes is equal to, can you help me now? Internal nodes how many? I want answer from you. Internal nodes how many? Those people who are typing, please stop typing, listen properly. Otherwise you are loser. Otherwise you are loser. Please type this. I will take care about their doubt. You listen here. In K array tree, every node contain K child or 0 child. That is normal. Next one. Number of internal nodes are I. Leaf nodes are L. Then find L value. Can you say total nodes is equal to internal nodes how many? And one more. It is a strict one. It is a strict K array tree. Means only one kind of internal node. So internal nodes how many? I into every internal node contain K people. Plus 1, because other than that nothing there, because remaining all are 0. So 1. So total nodes is equal to internal nodes into K plus 1. Now some people are asking, what is total nodes are? Total nodes are internal nodes plus leaf nodes, which is equal to Ik plus 1. Now I want L value. L is equal to Ik plus 1 minus I. I came this side. So if you common I value, right, I think it is a K, it is minus 1 plus 1. This is the formula. Number of leaf nodes is equal to, right, I into K minus 1 plus 1. This is the way of calculation. Don't by heart. Don't by heart. Don't by heart. Remember, internal nodes only. Listen, internal nodes only will give the story. Leaf nodes, see, leaf nodes are based on internal nodes. Right? Leaf nodes are based on internal nodes. Right? But in this diagram, in this problem, there is no one child. There is no two child. Everyone having K child. Everyone having K child. Be careful. Whatever procedure I am doing, this will work for every tree. Normal tree also you can write. In the normal tree, I1 people for K1, I2 people for K2, I3 people for K3, like that. But because of it is the strict one, only one choice. It is the strict one, only one choice. If normal binary tree, this is the story. Normal binary tree also I done same. I1 nodes having 2 children. I2 nodes having 1 child. Same thing I done. Finally, leaf nodes are internal node plus 1. Leaf nodes are I1s are not internal nodes. I1 plus 1. I1 plus 1. What is I1? Having 2 children. This one. Don't do blindly anything. Whatever procedure I done, see, observe from here. From here onwards, concentrate. From here onwards, concentrate. My actual story started from here. Today's major story started from here. Don't confuse. Children's means out degree. First understand. At anywhere, if you see from today onwards, a binary tree, children's are 5. Oh, right? Out degree 5. First understand. Now come to the story. What is the answer? A binary tree having, right? Listen, a binary tree having three people of 2 children. 3 people of 2 children. Next one. 3 people of 1 child. Plus 1, right? Leaf nodes no need to write, which is nothing but total nodes. Total nodes are totally this. I done the same story some other way. That is the next story. This is the one example assume for this model. See the second example what I written. In the binary tree, let us assume I1 nodes are having 2 children. I2 nodes are having 1 child. Remaining people are leaf nodes. We no need to say. Then total nodes is equal to I1 into 2 children, I2 into 1 child plus 1. If you do that, total nodes came, which is equal to what the total node? I1 nodes for 2 children, I2 nodes for 1 child plus leaf node. Finally, leaf nodes are this is, if you see the relation, leaf nodes is equal to number of people who are having 2 children plus 1. One child person cannot affect. So that is the one story what we done. That is example 2. Let's go to example 3. Same thing I extended. In a binary tree, 50 nodes are there with 2 children. 50 nodes with 2 children. Further information is not given. This is the only information what we have. Right? 1 child, no one is there. But we know very well, leaf nodes are based on 2 child only. 1 child not there, still we don't have any problem. For a binary tree, this is the story. Right? Now, I think that is example 3. Let's go to now one more new story started. What is K-array tree? I given definition. Sometime you will give definition like this. Same thing apply here. This is the story. Next one, example 5. This is the formula. Now come to anyone having any doubt now. Some people are asking, sir, why K minus 1 and not K in previous one? Why K minus 1? Where I written K minus 1? See, this I came this side. So L is equal to, if you common I, it became K minus 1. Common I, right? Here also I there, common. Then I into K minus 1 plus 1. L is equal to I into K minus 1 plus 1. If you have doubt, right? In this one, substitute. K value 3. Substitute. Leaf nodes how many? K value 3. Leaf nodes how many? And one more thing. Can you see in the above problem? This problem. How many internal nodes are there? How many people are having degree 3? How many people are having children's 3? We done already. 4. 4 people, substitute. I value 4. So leaf nodes is equal to I value 4 into K value 3. 3 minus 1 is 2. 4 into 2, 8. Plus 1, 9. Leaf nodes are 9. Check. Whatever I done over, I done here. The only thing is here formula, their number. Fine. Priyoshi, you got or you are saying okay? You got, you said okay. And one more, at any point of time, if you are not getting, right, at any point of time, if you are not getting related to binary trees, how many leaf nodes, how many non-leaf nodes, can you see the nodes one time? This part, can you check one time? My sincere request to everyone, if you don't get binary trees, k-array trees, number of leaf nodes, how many, number of internal nodes, how many, if anyone having small doubt, can you see from here onwards? Example 1 onwards, can you see? Example 1 to example 5. Can you verify one time? I have some doubt. Say what is the doubt? Say. What is the doubt? Say. Don't be afraid. I may shout because I am keep on saying 5 examples. If you didn't get, I may shout. That is okay. But you have doubt now. Please go ahead. These 5 examples, even all are similar. All are similar. One time you check. And from here onwards, you have to verify. Anyone having any doubt, please go ahead. Anyone having any doubt, please go ahead. I started with it. Listen, to say this story, to say all these 5 examples, I started this story. Listen, I started from here. From here, I started. Here. What is graph? Listen, I started from here. What is graph? What is tree? Oh, tree means connected always. Every tree is a graph. Tree don't have cycle. Tree contain v-1 edges. Okay, I think you got that tree. Next question. What is the leaf node definition? If it is an undirected graph, leaf node, right? 0, right? Leaf node means degree 1. If it is a tree, but undirected graph, means degree 1 leaf node. Next one, directed graph, out degree 0 leaf node. Remaining people are internal nodes, not leaf nodes. Now I enter into my story. Yeah. Now see. In previous example, binary tree leaf node was internal nodes with 2 child. See, normal binary tree. Can you see this one? Normal binary tree. Can you see this one? See. Yeah, this one. Everyone observe. Everyone observe here. Normal binary tree. See this one. The story, whatever I written, listen. The story, whatever I written, it will work for everyone. See, final observation, what you got? Number of leaf nodes is equal to number of nodes with the, right? Number of internal nodes with the 2 child. Number of internal nodes with the 2 child plus 1. This is for normal binary tree. In the normal binary tree, you may find out 1 child also. In the normal binary tree, you may find out 1 child also. But if you want leaf nodes, 1 child, people cannot create any trouble. If you want leaf nodes, right, 1 child person cannot create any problem with the leaf node. So in the normal binary tree, we have this also. Finally, we got this. Now, if you go to the k-array tree, 1 child cannot be there. Everyone having k, right? Leaf nodes are directly based on this. Everyone having k child. Leaf nodes are directly based on this one. Can you help me now? What is the answer you got? Leaf nodes is equal to 13 minus I. But previous one, how much? Plus 1 or minus 1? Here plus 1. It is a normal binary tree story. Normal binary tree story is this one, right? If at all k-array tree, this is the one. Apply same procedure. Don't by heart the formula. Procedure apply. You apply the procedure, you will get the answer. Right? Priyoshi, apply the procedure. Don't, if you remember this formula, you may get some wrong answers. Because this is for normal binary tree. This is for, right, k-array tree. This is for k-array tree. But procedure is same. K-array tree, normal binary tree, procedure same. But finally, they little bit differ because there is a 1 child here. There is no 1 child here. That is the reason little bit affected. See, here I think what is the answer? Total nodes are these many. Total nodes are these many. Leaf nodes are here minus. Right? 13 minus 4, which is the internal nodes. Right? Fine. Right, fine. So make sure procedure, same procedure I applied here. Same procedure I applied here. One or two doubts are there. If anyone think that, sir, I have doubt, just revise one more time. Just revise one more time. So I discussed something about leaf node, internal nodes, k-array tree, next one, strict k-array tree, normal k-array tree, everything I explained. Right? Everything I explained. Normal k-array tree, everything I explained. Right? Fine. Now only for namesake. Only for namesake. Can you see this one? Only for namesake. Can you see this? Everyone, can you see this? Don't confuse. Procedure only important, not formula. Even I don't know formula. Anyone confused? Are you at least comfortable? Whatever I am going to do now on the board. Are you at least comfortable? Whatever I am going to do now on the board. Everyone observe. Everyone observe. K-array tree. I am giving the new definition. Don't confuse. K-array tree. Let us assume that K-array tree means every person having zero child, one child, or two child, and so on, k child, maximum k. K-array tree, every person having zero child, or one child, or two child, or k child, maximum k child. Let us assume that it is the new definition. Sometimes he will say k or 0. Sometimes he will say 0 to k, anything is okay. Right? Now see. Now after giving this one, let us assume that k is 4. Let us assume that k is 4. Okay. 4 children's maximum allowed. 4 children's maximum allowed. Every person allowed maximum 4 children. Sometimes 2 also okay. Sometimes 3 also okay. Sometimes 1 also okay. Sometimes 4 also okay. Sometimes 2 also okay. Sometimes 3 also okay. Let us assume. Now come here. Our actual procedure I am following. Listen now. Total nodes is equal to. Can anyone help me now? 4 children, how many? 3 children, how many? 2 children, how many? 1 children, how many? Lastly, plus 1. Now complete one by one. 4 children, how many? Count. If you are okay with this, you are okay with everything. Standard procedure, don't by heart. Standard procedure, don't by heart. Can you help me now? 4 children, how many? In the place of binary, I kept k. 4 children, how many? 2 people? Yeah, 4 into 2. 3 children, how many? 3 children, how many? 1, 2. 2 children, how many? 2 children, how many? 1, 2. Is it 2? Is it 2? Yeah, next one. 1 child, how many? 1 child, how many? Check. 1 child, how many? Check. Arey, 1 child, yaar. 1 child, 1. Yeah, if you want, I will add one more also. If you want, I will add one more also. Can you count 1 child, how many? 1. Child means out degree. 3. Now count total. Now. 4 into 2, 8. 3 into 2, 6. 2 into 2, 4. 1 into 3, 3 plus 1. Count total. 8 plus 6, 14. 14 plus 4, 18. 18 plus 3, 21 plus 1, 22. Can you count total nodes are 22? Same procedure for everyone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Am I right? So every time same. Whatever information given, use it. Whatever information given, use it. Now come to one more story. See this one. Four children, 2 people. So total nodes means everyone is in. Total nodes means internal nodes plus leaf nodes. When you say total nodes, internal nodes plus leaf node. Who are the internal node? 4 children also internal node, 2 people. Next one. I think 3 children also internal nodes, 2 people. Next one. 2 children also internal nodes, 2 people. Next one. 1 child also internal nodes, 3 people. These all are internal nodes. Right? Next one, leaf node. Leaf node means 0 child. So I think I don't have in this one. I don't have. So keep as it is. So this will become, see this one. I think 2 plus 2, 4, 4 plus 2, 6, 6 plus 3, 9. See this one, 9 plus leaf nodes is equal to 22. Leaf nodes is equal to 22 minus 9. How much? 22 minus 9. What is the answer? 22 minus 9. What is the answer? 11. 11? No. 13? 13? Yeah, 13. Now, can you count? Can you count properly? Leaf nodes are 13 or not count? Leaf nodes are 13 or not count? Leaf nodes are 13 or not count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Same story here. Whatever information given, this is the highlight of the story. Apply this formula every time. This is a internal node. It is also internal node. It is also internal node. It is also internal node. Total nodes means internal node plus leaf node. Listen, whatever procedure I explained now, this is the example 6. Whatever procedure I explained now, any tree it will work. Any tree it will work. Procedure is same. Procedure same. Every person, normal binary tree, strict binary tree, everyone will work. Procedure same. Finally, what result will come, I don't know. This is the procedure. Everyone apply the same procedure. Everyone apply the same procedure. Sometimes you will say K array tree, 0 or K. I applied the same procedure for that also. See, this is the thing what I got. This is the thing what I got. See, in K array tree, every node contain K or 0. K or 0 means I think 1 not there, 2 not there, 3 not there. K or 0. So, okay. I into K. I, right? I people, internal nodes are I. But everyone is, internal node means what? Children are there. K child or 0 child. What is the meaning? Oh, K child or 0 child. So every internal node contain K only. So plus 1. So total nodes I plus L is equal to this one. L is equal to this is the formula. If you by heart, you are the loser. I never seen someone in the GATE examination who by hearted, who got the very good rank. Who by hearted and he got the very good rank. I never seen anyone. Even I also don't know this formula. I know the concept, right? I applied. I know the concept. Oh, this is the concept. I applied. Right? So please check if anything wrong, I will rectify. I never seen one student who by hearted and he got the nice rank. Yeah, can we move to next? One nice story happened. Any tree it will work. Binary tree, ternary tree, K array tree, strict binary tree, anyone it will work. It will work for complete binary tree also. It will work for strict binary tree also. It will work for K array tree also. It will work for ternary tree also. Anything it will work. I don't know the final result, right? Sometimes children's one child there, sometimes one child not there. Minor changes are there, but procedure is same. Everywhere apply the story. Everywhere apply the story. Children's means out degree. When he say in the problem, I1 people are having 3 children. Oh, 3 out degree. Children's means out degree. Right. You are okay now. If you okay, I can proceed further. If you are okay, I can proceed further. We really done good work. 1 or 2 doubts are there. Revise here. Revise here. Nothing will happen. In life, nothing will happen. If you are not getting, revise. If you are not getting, revise. If you have dare, ask in the class. You have dare, you have doubt. Not only having doubt, you should have dare also. Sir, I have dare, sir. I have doubt also. Ask. I have doubt, sir, but I don't have dare, sir. Then revise one more time. What you will get? What you lose? You have doubt also, you have dare also. Ask. I have only doubt, sir. I don't have dare. Revise. But get in the class itself. Get in the class itself. Don't postpone unnecessarily. Don't postpone unnecessarily. Are Shiva, Shiva, are you getting? Are Shiva, are you getting? Shiva, are you getting? No, no, he's gone. He's gone. Sir, please upload this PDF in group or app. Why? It is my notes. It is my notes. Why you want? Arey, write notes properly, yaar. Roz, write your notes, yaar. Write your notes, man. Where is that Shiva? Where is that Shiva, yaar? No, no, he's not there. Now I will give one problem. I don't know how many people will give answer. What is the meaning of size of a graph? What is the meaning of size of a graph? Size increases. What is the meaning? Edges are increases. Size is increases. Number of edges are increases. Size is increases. Number of edges are increases. Remember that. Some questions are there based on that. Right? Fine. Fine. Now I'm going to give one problem. Yeah, take this. How many people will give answer? Let's see. Let's see how many people will give. This is given in one of the GATE examination. This question is given in one of the GATE exam. Let's try. What is the number of vertices in undirected connected graph with 27 edges? What is the number of vertices? Is asking number of vertices. Remember, in this problem is asking, please find the number of vertices, but some information given, right? Some information is given. What is the information given? Is saying undirected connected graph. G is undirected connected graph. Okay, that is some information given. Next one is given number of edges also. Edges as 27. And one more thing is mentioned, 6 vertices of degree 2. Three vertices of degree 4. and remaining degree 3. Remaining of degree 3. Yeah, this is the information given. Finally is asking, what is a how many calculate? Yeah, can you try this? He's saying there is a graph which is undirected and connected graph. That graph contains 27 edges. That graph contains 27 edges, 6 vertices of degree 2, 3 vertices of degree 4, remaining vertices of degree 3. How many vertices are there is asking. Try whatever you are thinking. Yeah, can I give answer? Can I give answer for this? Yeah. So many people are saying 19. I will try. Many people are saying, right? Many people are saying 19. I will try. Can anyone help me now? He is asking, everyone observe. He is asking number of vertices how many? He is asking number of vertices how many? Let us assume number of vertices are n. Assume. He is asking number of vertices how many? Assume n vertices. Assume n. Now listen. Now listen, everyone. Do you know this formula? Sum of degrees is equal to 2 into E. Do you know this? Do you know this formula? Sum of degrees is 2E. Sum of degrees is 2E. Do you know this? If you know this is nothing but 2 into 27, which is 54, right? But sum of degrees is 54. But how to write sum of degrees? Let's start. Sum of degrees. Can you help me now? 6 vertices of how much? Degree 2. 6 vertices of degree 2. Next, 3 vertices of degree 4. Next, See the answer. 6 vertices are degree 2, 3 vertices of degree 4. Until now done. Can you say until now how many vertices are over? 6 vertices, 3 vertices. 9 vertices are over. Out of n vertices, only 9 over. Remaining n minus 9 people of degree 3. Remaining is n minus 9. Because 6 plus 3 is 9. So which will goes to 12 plus 3n minus 3 9s 27, which is going to be 54. I think it is I think 24. It is a 27. I think remaining is 3 left out. 3n minus 3 is equal to 54. 3n is equal to this one 57. N is equal to 57 by 3, so 19. Fine. Everyone know this. See, everyone have to understand one thing. Everyone have to understand one thing. Some problems looks easy, some problems look tough. Some new things will come, some old things will repeat. Life is combination of all. Every time enjoyment not possible. Sometimes you have to cry also. In life, sometimes you have to laugh. Sometimes you have to cry. See, this became how much easy. See, this problem became how much easy. Please check. Everyone knows. Everyone knows. But see the previous problem. Little tough. Because maybe first time you are listening. So that is the reason it became little tough. When you listen first time, some tough. You revise one more time. Yeah, can I move to next problem? Sir, time. What time? Yeah, I think, see, today there is no C programming. Can I continue little more? Or you want? Please let me know. Can I continue C programming? Check yourself. Someone is saying, then we can do this class up to 10. If anyone die, you are responsible. Please write the letter. If anyone die, right? My name is Sayan. If anyone die, I am responsible. Arey Sayan, you write the letter. Continue this class since no C. Yeah, right. Are you getting everything? No, this one, are you getting everything? We'll say few more problems. We will say few more problems. Yeah. Now, can you see this problem also? It's very interesting. I don't know how many people will do. Let's check. The maximum number of edges, in a bipartite graph on 12 vertices is, it's one of the numerical problem which given in the previous papers. The maximum number of edges in a bipartite graph on 12 vertices is. Check properly. The maximum number of edges in a bipartite graph on 12 vertices is? So my first question to everyone, is he asking maximum edges or minimum edges? My first question to everyone, is he asking maximum edges or minimum edges? Okay, maximum. Right, I understood. And one more thing. When you say bipartite, two parts or one part? When you are saying bipartite graph, right, one partition or two partition? Two partition. So without giving the partition, how you can give this problem? Listen everyone now. Without giving partition, how can he give the problem? See this one. I have 12 vertices. Listen. I have 12 vertices. He's saying that in the bipartite graph with 12 vertices, what are the maximum edges possible? Actually, bipartite means you have to divide. Without dividing, how he can give? Yeah, that is the question he is asking, right? If I divide in what way, I will get maximum edges. So what is the meaning? Because of 12 people, if I divide in what way, I will get the maximum edges. So what is the answer? One combination, one vertex here, 11 vertices here. One more combination, 2 here, I think 10 here. One more combination, 3 here, 9 here. One more combination, 4 here, 8 here. One more combination, 5 here, 7 here. One more combination, 6 here, 6 here. I think this will be reverse, ulta. It will happen ulta. Either 5, 7 or 7, 5, both are same. Next one, 7, 5. It will keep on going. I think this story not required. So these are the possibilities. Suppose assume those 12 vertices, luckily you divided like this. Now everyone now, complete bipartite graph contain here m people, here n people, mn, 11 edges only will come. Suppose if you divide like this, 2 into 10, 20 edges will come. If you divide like this, 3 into 9, 27 edges only will come. If you divide like this, 4, 8, 32, 32 edges only will come. If you divide like this, 35 will come. If you divide like this, Bhagavan Maharshi, right? 36 came. That's it. He is given the chance to you to divide whatever way you like. Suppose assume that he divided. Can you help me now? If he divide, there is no question of maximum. Am I right or not? If he, listen, if himself divided, where is the maximum? Only one answer. Let us assume that's this one. Listen everyone now, the maximum number of edges in a bipartite graph on 12 vertices where partition is 3, 9. What is the answer? 3 9s 27. If himself he say only 27. Because bipartite graph maximum edges are 3, 9, 27. He is not divided. He is saying what way I have to divide so that I will get the maximum edges. So answer is, I think you have to divide equally. Are you okay with this problem? See how much story there inside. The only thing is you should know first of all what is bipartite. Bipartite means partition required. You have 12 vertices. How you do partition? Yeah. What is the answer? Divide in such a way that where more edges will come. Now, somewhere I seen this problem also. Listen, in one of your previous paper, I seen this problem also. See the problem. Maximum number of edges possible. See this one. Maximum number of edges possible in a bipartite graph on n vertices. On n vertices. Then what is the answer? Total is n vertices. Divide into two equal parts. Divide into two equal. N by 2 this side, n by 2 this side. Then n by 2 into n by 2, which is nothing but n square by 4, which is equal to n square by 4, where n is even. If anyone having problems, sir, some fractions may come. Let us assume that n is even, so that no fractions. If you divide equally, you will get the maximum benefit. Same thing. When you are listen, when you are distributing when mama papa distributing their property to you, when mama papa distributing their property to you as the kids, as the next generation people, take everyone equally. Take everyone equally, if possible. Everything also give to your sibling, right? Don't, like a thief, don't steal from them. Assume that papa having 10 crore. You people are having 2 kids, right? You people are having 2 kids. So give to papa 10 crores are there, 4 crore, remaining 6 crore, divide to both people, 3 crore. Right? Don't take you 5, right? Don't give to your sibling 1 crore. Don't do that. If you divide equally, if you behave like a gentleman, you will grow in your life. Maximum profit will come. You will get the maximum profit. If you divide equally, you will get the maximum profit. If you steal like a thief, some other thief will come, right? He will steal from you. Samjha? Arey Raj, samjha? Don't steal like a thief. Right? Divide equally. Then you will get the maximum profit. See, maximum profit came, see, equally divided, maximum profit. Always remember, balancing property will make your life. Balancing, you have to balance. If you go one side, problems will come. Yeah, can I move to next problem? I think this also okay. Can I move to next problem? Yeah, let's see one more problem. Let's see. With that we will go. Let T be a tree with 10 vertices. Then the sum of degrees of all vertices in T is, in one of the exam, this question is given, numerical type question. What is the answer? Let T be a tree with 10 vertices, then the sum of degrees of all vertices in T is. Now, one small question I want to ask you. Listen, one small question I want to ask you. Is he asking in degree or out degree or degree? Is he asking in degree or out degree or degree? Degree. Degree means normal graph. Normal story. Until unless he will say in degree, until unless he will say out degree, until unless he will say children, don't consider as normal, right? Don't consider as different. So it is a normal degree. No need to bother that much. Normal degree. It is not children. It is a normal degree. Right. Now come here. Interesting answer. Interesting answer. Let T be a tree with 10 vertices. Then the sum of degrees of all vertices in T is. Now listen. Now listen. Do you know this formula? Do you know this formula? See this. Sum of degrees. Sum of degrees is equal to 2 into E. Will you agree? Will you agree this line? Sum of degrees is equal to 2 into E. Will you agree? Yeah. If you agree, listen, if you agree, 2 into, can anyone say? It is a tree. It is a tree with 10 vertices. How many edges by a? 9 edges. How many edges by a? 9, because it is a tree. 10 vertices, a tree, 9 edges. So 2 into 9, 18. Sum of degrees is 18. It is a tree. 10 vertices. 10 vertices tree contain 9 edges. Sum of degrees is equal to 2 into E. E value 9. 2 into 9, 18. Fine. Are you okay? Are you okay? Yeah. And one more. This problem, listen, this problem will kill you in the place of a tree graph there. Am I right? Am I right? In the place of tree, graph is there. Over. Game is over. Right? Game is over. In the place of tree, graph there. Game almost over. 10 vertices. How many edges are there? How I know? 10 vertices are there. How many edges are there? How I know? In the graph, 10 vertices are there. 10 vertex graph edges. Maybe 0, maybe 1, maybe 2, maybe 3. Maximum 10 into 9 by 2, 90 by 2, 45. 0 to 45. Anything is possible. 0 to 45, anything is possible. Number of edges. By using the keyword tree, killed this problem. If anyone is not getting answer of this problem, very simple. You didn't catch it, this word tree. 10 vertices, 9 edges. Right? Sum of degrees is equal to 2 into E. Right? 2 into 9, 18. Now, if you have small doubt also, can you see this? If you have small doubt also, can you see this? Can you see this one? How many edges? Otherwise, can you check how many vertices? It is a tree. How many vertices can you count? 7. Number of edges should be 6. 2 into 6. Number of edges are 6. Whenever you say 7 vertices, 6 edges, check. 1, 2, 3, 4, 5, 6. 6 edges are there. 2 into 6, totally 12. Sum of degrees are 12. You may say that, sir, how? See this one. Here degree, not children's. Here degree only. Degree is different, children's are different. When you say children, out degree. But when you say degree, everything you can count. See, degree 2 here. Here degree how much? Here also 2. 2 or 3? Here 3. Because see, 1, 2, 3. Here degree how much? 3. Here degree how much? 1. 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 Can you count total? 2 3s are there, 6. 6 plus 2 there, 8. 8 plus 4 there, 12. That's it. Some people are asking, how can you say degree 3 here? How can you say degree 3? Array buffoon. It is a graph. It is a graph, buffoon. What is the meaning of degree? Everything you have to count. It is not children. Sum of degrees, not sum of children. Sum of degree. It is a degree, normal degree. So for this person, degree 3. Children's may be 2. But when you say, listen, when you say children's and all, out degree, out degree. It is simply degree. So I think for the A, degree 2, for the B, degree 3, for the C, degree 3, for the D, degree 1, E, degree 1, F, degree 1, G, degree 1. So it's finally going to be 3 plus 3 plus 2 plus 4, which is going to be 12. Yeah, are you okay? This problem will kill you in the place of tree graph there. In the place of tree graph is there, this problem will kill you. Right? Fine. Yeah. I will say one small story. With that, we will end it. I will say one small story there. I will say that with that, I will end it. Right? Listen everyone. One small story I will say, just listen. A. Until now I didn't say, but it will be useful many places. A, B, C, D. A, B, C, D. Yeah, fine. Now I will ask you one small question. Careful everyone. In all these 5 people, A, B, C, D, E, what is the okay, let me remove this. Yeah, in all these 5 vertices A, B, C, D, E, what is the A degree? One nice story there. Can you listen this also? A degree 3, B degree 3, C degree 3, D degree 3, E degree 4. Fine. Are you okay? Yeah. If you want to make it a little more interesting, I'm deleting one person. This person I'm deleting. Yeah. Now can you say modified one? C and D modified one. What is the answer? C and D modified one. What is the answer? C degree 2, D degree 2, E degree 4, A degree 3, B degree 3. So like that all are there. Now observe. Careful everyone. Sum of degrees is it 2 into E? Sum of degrees is it 2 into E? 2 into what is the E? How many edges are there? Can you see the graph? I think inside 2, inside 4, outside 3, I think 7 people. 2 sevens 14. I think sum of degrees is 14. If you want, you can count. 6 plus 4, 10 plus 4, 14. Sum of degrees is 14. Sum of degrees is 14. Can anyone help? 2 into E is sum of degrees. 2 into E is sum of degrees. This is 14. Sum of degrees is 14. Can you help? Sum of degrees is 14. Everyone observe. Sum of degrees is 14. Then what you do is divide this 14 by how many vertices are there? Sum of degrees are 14. Divide this 14 by number of vertices. Divide by number of vertices, which is equal to I am writing here, which is equal to 14 by 4 or 5. How much? Sum of degrees, find out 14. Divide by number of vertices. 14 by 5. How much? Write fractions also. Write fractions also. Are 14 by 5, yeah, not 2. Because of 5 vertices are there. 5 2s 10. 2 point something? Yeah, 2.8. This is 2.8. Now listen. This is called This is called average degree. This is called average degree. Just to find out sum of degrees, divide by number of vertices you do. You will get the average degree. Take the all the students' marks, divide by number of students, average marks you will get. In the similar way, sum of all degrees you take, divide by number of vertices you do, you will get the average degree. Will you agree? This is the average degree. Am I right? This is average degree. Some people are asking, sir, how to calculate average degree, sir? Sir, how to calculate average degree? Sum of degrees you find out first. Divide by number of vertices. It will give average degree. So average degree 2.8. Now listen everyone. Now listen everyone. In this graph, who is the minimum degree? 2. Minimum degree 2. Less than or equal to. Average degree 2.8. Less than or equal to. Maximum degree 4. Remember. So minimum degree less than or equal to average degree less than or equal to maximum degree. How you got the average degree? Like this. So for every simple graph, this rule will be applicable. What is that one? Minimum degree, any simple graph you take, minimum degree less than or equal to average degree less than or equal to maximum degree. Sometimes maybe all equal. For the complete graph, all equal. For the null graph, all equal. Suppose graph is a complete graph. If you want, you can check. Graph is a complete graph. Then every person degree 3. Check if you want. 3, 3, 3, 3, 3, 4 times. Sum of degrees are 4 into 3. Sum of degrees are 4 into 3, 12. But when you say average, 12 by again 4 people. 12 by 4, 4 can 3 come. Minimum degree 3, maximum degree 3, average degree also 3. Sometimes equal also. That is the reason equal also available. For some graph, minimum, maximum, average, all are same. For some graph, minimum is smaller. If you want, you can check in this graph. In this graph, you can check minimum is 2, maximum is 4, average is 2.8. Sometimes need not be equal, but one thing is true. Minimum cannot be greater than average. Average cannot be greater than max. Remember, either all will be equal or minimum less than average less than max. Sometimes minimum is small, sometimes maximum bigger, right? But this condition always hold good, less than or equal to. Minimum degree less than or equal to, average degree less than or equal to, maximum degree. Is there anyone who is having doubt in this? Minimum degree less than or equal to, average degree less than or equal to, maximum degree. How to find out average degree? Sum of degrees find out. Divide by number of vertices you do. Sum of degrees is 2e. Divide by v you do, number of vertices. Then you will get the average degree, 2.8. Now for this one, what is the average degree? See this one, sum of degrees. 4 vertices, every vertex degree 3. This is the sum of degrees. Divide by number of vertices 4, 3k. Minimum degree already 3, maximum degree already 3. Null graph, all are 0. But you never show one graph to me where minimum degree greater than average. It never possible. You never show one graph to me where average degree greater than maximum degree. It is impossible. It's impossible. Please take care of this. Based on this, in the previous paper, many problems are there. If I go directly, you will die. That is the reason I explained this. If I go directly, you feel so scared from where it came. You feel so scared about this. Right? Remember, we will discuss only simple graphs. Any question you find out in the previous paper, multi-graph, please let me know. Then I will teach that also. I didn't see one also. If you find it anywhere in the practice tests also, anywhere, So you utilize all PYQs available inside the app. Utilize all of them, right? First of all, complete weekly test. Nodes and weekly test first. Don't go directly here and there. First nodes. No, without nodes, if you move here and there, problems will come. Note that class nodes first. Next one, right? Next one, weekly test next. Next one, PYQs next. This is the procedure. Each vertex of G has degree at least 3. Yeah, now see this. Now see this. This one, sum of degrees. Listen, sum of degrees. Sum of degrees is 2 into E. Will you agree? Yeah, what is the E value? 25. Right? Sum of degrees is equal to 50. Yeah, till now everyone is comfortable. Till now everyone is comfortable. But one thing I want to ask you. Is he asking number of vertices? Is he asking number of vertices? Bhaiya, is he asking number of vertices? Yeah, he is asking number of vertices. Let us assume that number of vertices are right. Then the maximum possible value of n is n vertices are there. He himself saying n vertices. Can you help me? You only say every vertex degree is minimum 3. Minimum 3. So every person is 3, 3, 3, 3, 3. So can I say this 3 into n is less than or equal to 50? Can I say this? If at all everyone is equally, if at all equal, if it is equal, can you help me now? Can you help me now? Is it small or less? Forget about other area. Forget about other area. This is small or less? This is small or more? This is small or more? Small or not? Small. Every person is minimum 3. That is the reason I written less than or equal to. I didn't written greater than or equal to. If I taken more, I could have written greater than or equal to. If I taken equal, I could have written equal. I took less. This value is less than or equal to 50. Everyone knows. So I took less because everyone is 3 or more than 3. Some people may be 5 also. Some people may be 7 also. But I taken only 3. So this is less than or equal to 50. Now can you help me? This is less than or equal to 50. So n is less than or equal to 50 by 3. How much? N is less than or equal to 50 by 3. So how much? 16 3 is 48. 2 there. 3 6 18. I think 16.6. Listen, n value should be less than or equal to 16.6. Can anyone help me? N should be, listen, n should be maybe 5, maybe 10, maybe 15, maybe 16, but not more than 16.6. But remember, number of vertices cannot be a fraction, but you cannot take more than this. So what is the answer? N is equal to 16 is a better idea. Am I right? You may say that, sir, can I take 17, sir? You cannot take more than this. You cannot take more than this. N should be less than or equal to 16.6. Either this or less, but fractions not allowed. I think 16 is the better idea. Will you agree with this? Check if anyone having any doubt. Check if anyone having any doubt. Sir, then only 48 degrees will come, right? That's what he's asking. Maximum possible value. Then maximum possible value. Fine. This is the maximum. Can you help me one small line now? Can you help me one small line with 40? Listen, with the 16 vertices, actually how many edges possible? If it is a complete graph, how many possible? 16 into 15 by 2. 16 into 15 by 2. I think 2 cancel 8. 8 15 is 120. 120 edges actually, but right in this graph, only 25 edges are there. Someone is saying that if that is the case, only 48 will come. Only 48. If you take 17, then it will become 51. So that is the reason maximum possible value of n. Because we have boundary, n cannot be more than that. We have boundary, n cannot be more than that. Fine. Is it okay? If you take 17, it will become 51. So maximum possible value. So see this one. It is a less than or equal to. That is the reason I written less than or equal to. Less than or equal to. You will get either less or equal. You don't get more. Less than or equal. Anyone having doubt? Check one time if anyone having doubt. G is an undirected graph with n vertices and 25 edges, such that each vertex of G has a degree at least 3. Then the maximum possible value of n is. Fine. Can we move to next? Can we move to next? Yeah, fine. Yeah, let me give the problem. Yeah. Check the following graphs are. Check the following graphs, which is planar, which is not planar. Yeah, some graph, nothing there. So whatever is given, same graph as it is. As it is. Next one. G2. Let's go for a G3 also. Yeah, I think this is the diagram. Can you try yourself which are planar? Yeah, this is the next problem. This is the next problem. So yeah, can you try this? Someone is saying for the G2, should I consider 2D or 3D? Consider 5D. Bhaiya, consider 5D. Array, one graph is given. Just check is it planar or not. What is 3D? What is 4D? What is 5D? Simply vertices, edges are there. Simply vertices and edges are there, right? What is 3D? What is 4D? Yeah, Sophia saying that G1 is not. I think G1 is a direct one or not? G1 is a direct one or not? It is a K, I think it is a K33. G1 is K33. Everyone know this. Yeah, so it is not planar. Everyone know. G1 cannot be. Yeah, what about G2? Yeah, what about G3? What about G3? I think inside there is a crossing there. Can you draw that diagram without crossing? Outside people, no problem. Outside people, no problem, I think. So I think he will go like this. Yeah, it is a serious issue. So D2C, I cannot go from inside. I cannot go from outside also. If you go inside, I think here problem. If you go from outside, here problem. If I go from this side, here problem. So G3 also not. But if you see the G2 also edge crossing there. G2 also edge crossing there. G2 also edge crossing there. Can I write this one without edge crossing? Let's check. Let's check this one. So until now there is no problem. Until now there is no problem. Am I right? This also no problem. This also no problem. I think two people are having problem. Two people are having problem. Who are those? Two people are having problem. Who are those? Someone is saying AE having problem. Yeah, AE having problem. Next. I think DH also having problem, right? I think they are the only two things. Remaining things are okay. Okay, now see what I'm doing. So is there any way to do this? Is there any way to do this? I think I'm trying like this. I'm trying like this. See this one? A, B, C. Listen, I am writing D here. I am writing D here. So this one I can keep. Right? This one I can keep. And one more thing is, yeah. So C to D also one edge there. I will keep here. Anything else? I think H to D also there, like this. Fine. Is it fine now? I took the D out. So D having 3 people. D having 3 people. Anyone missing? I think this also missing. D having degree 3. I think I maintained it. I maintained this. C having 3. I done it. C having 3. I done it. All are fine now. All are fine now. Is it planar? Sir, can we change the shape? See, without changing the meaning, right? Johan, do whatever way you want. That is the given graph. Whether you change the shape or whether you don't change, at the end of the day, same diagram. You write whatever way you want. I think every person degree 3. So that's what I'm saying, right? There is no 3D, there is no 4D, there is no 5D. Simply vertices and edges. Simply vertices and edges. Can you draw all edges? Can you draw all edges without crossing? Now is it fine now? I written one model. You write any other model. I don't have any problem. Am I covered or not? Check. D having degree 3. I done it. You can do some other way. You can do some other way. Simply, the concept is very clear. The concept is very clear. Without edge crossing, can you draw? You may be having some other plan. You may be having some other plan. What is the idea here? Can you draw all edges without crossing? If anyone says or some other way, that is also correct. Your answer also correct, because I cannot see your answer. Your answer also correct. But can you draw without crossing? It is very simple here. At which place crossing is there? Avoid that. At which place you thought crossing is there? Please avoid. There may be some other way. Some people are asking, sir, can I make right E? Can I make E out? That is also okay. Can I make E out? Either you make D out or E out. Do whatever you want. Right? Because of D people, E people, crossing is there. Because of D people, E people, crossing is there. Keep them out. Keep them out. Fine, one person out is enough. So I think G1 cannot be, G2 cannot be, sorry, G3 cannot be. G2 is okay or not? G2 is planar. Okay. Okay. Are Johan, you okay? Johan, you may be having some other way. That is also correct. So without using some complex lines, do whatever way you want. See, we have to give answer within 2 minutes or within 3 minutes, maximum 3 minutes. Do whatever is possible. I know planar. Oh, without edge crossing, I have to do. Without edge crossing, I have to do. Right, like that. Now listen. If G2 is planar, I want answer from everyone. If G2 is planar. Final conclusion. If G2 is planar. Yeah, if we can shift vertices, then we can shift vertices of G3 also. Shift. Do whatever you want. Shakir saying G3 vertices also I will shift. Are where is shifting here? Same diagram you write, whatever way you like. But the property should be same. What is the meaning? How many vertices are there? All vertices should come. How many edges are there? All edges should come. The only thing is crossing cannot be there. That is the only criteria. That is the only criteria. Hidden, can we go? Hidden, can we go? Someone is saying without diagonal, anything is fine. Anything is fine. Simply graph here. Don't bring complex lines. Don't bring complex lines. Just here vertices are there, edges are there. It look, listen everyone now. Listen everyone now. This is the problem with the eyes or not? Eyes, this is the problem with the eyes. The problem with eyes is by seeing that eyes will say it is a dangerous diagram. Who asked you to see with eyes? Just a calculation, vertices, edges. The problem with the God is given eyes, right? It is having so many advantages. It is having so many drawbacks also. Because by seeing the problem with eyes, we are forgetting the brain power we are forgetting. When you see the problem with eyes, it look like, oh, so scary. Oh, very danger. Who asked you to see with eyes? Who asked you to see with eyes? This graph contains vertices, edges. Without crossing, can you draw? God given eyes, yeah, it's wonderful, true. God is given eyes, it's wonderful, true. But the problem is, we are scaring by seeing problem. Just to follow rules. What is that one? Oh, all vertices I have to take. All edges I have to take without crossing. Now, come to the next story. Come to the next story. One small story. I want to say one small story to you. Listen. Listen one time. Everyone listen. Someone is saying that G3 can be planar by changing the C position. Yeah, where I have to change? Where I have to change C? Say, I will do that. Above A. Above A. Let's try. Let's try. Can I try or not? Please let me know. Whoever saying try, can I try? So let's try. A, B, D, E, F. Now I think someone is saying C. Okay. Then these all are there. This also there. This also there. This also there. This also there. Next. Next. B to C. Next. Where is the crossing? Check, are we missing anything? Yeah, it's not B2CR, it is the D2C. It is not B2C, D2C, na? People are like this. I am almost dead. I am clueless. Trust me, I am almost dead. I am almost dead. Only for namesake I survived. Only for namesake I survived. So I think D2C. D2C. Yeah, I think it's closed. Problem came. Only crying left out. I don't know. I don't know how it happened. Just only crying left out. If at all video camera is not on, if camera is not on, I could have cried. I too died for a second. The person who given this stupid idea, is so happy. Oh, Reddy sir red-handedly caught. I caught Reddy sir red-handedly. He is dancing almost. Are Gootle, whoever said this idea, right? He is dancing inside. Yes, I caught red-handedly. Now see, bhaiya, now see. Now see. Someone is saying, go from Nietzsche. Someone is saying, go from Nietzsche. Go, bhaiya, go. Bhaiya, from Nietzsche jao na. Jao from Nietzsche. Jao from Nietzsche na. Nietzsche jao bhaiya. Are buffoon. Are Johan, are you there? Johan, are you there? He's gone. He's gone. He's like this every time. He's like this. Every time he's like this. Oh, he's there. Are today is not my day or what? Everyone is catching me. Everyone caught me. Today is not my day or what? I thought he's gone. I started shouting also. He's gone. He's gone. I started shouting also. He came back. My sixth sense saying that Johan gone. My sixth sense saying that Johan gone. Okay. It looks like a nice diagram. It looks like a nice diagram. It looks like a devil. It looked like a devil. Sophia said B2E edge. B2 edge. B2E edge. Oh, which edge there then? B2E there, na? D2C. Initially, we thought B2C. Actually, it's the B2E. So, right, I think D2C. Yeah, fine, perfect. Who said go from Nietzsche? Who said go from Nietzsche? Who is that idiot said go, right? I don't know, sir. Someone said go from Nietzsche. Draw from Nietzsche, na? Draw from Nietzsche, na? So, see, there is a chat also. You cannot hide it. You cannot hide it. There is a chat also. I am able to see all. I don't know whether you are able to see or not. So, let's see. There is a person. Yeah, someone said that B2E from bottom. Someone said B2E from bottom. Are Gootle. Someone said B2, Shakir only. B2E from bottom. No crossing. He is celebrating also. He is celebrating also. B2E from bottom. No crossing also. He is celebrating. I seen his celebrations also. I almost dead, man. Dead. Two things scared me till now. Two things are scared me. One is this one is my madam after marriage. Before marriage, she is so sweet. After marriage, almost cried. Right? After marriage, before marriage, my madam is so sweet. After marriage, almost I cried. This is the same thing. 2 times I cried in my life. One is this, one is after marriage, my madam. Recording is on. So what? My madam don't watch. So what, man? I locked the door also. I locked the door also. So what? I locked the door, yeah. Soundproof. Soundproof, yeah. Soundproof. It is a soundproof. Room is soundproof. Chalo then. Next problem. Next problem. I think you got clarity. Next problem. Now listen. Now everyone listen. Everyone listen. One small story there, someone is diverted. One small story there, someone is diverted. Let's come here. Let's come. See everyone. Is it planar? Be careful. Is it planar? Everyone observe. Everyone observe. Is it planar? Yes. If it is a planar, if you say if it is a planar, let me ask one by one. In this graph, in this planar graph, how many vertices are there? In this planar graph, how many vertices are there? Can you count? How many vertices are there? Can you count? I think 4. If you want, you can see over also. 4 plus 4, 8. 8 vertices. Can you count how many edges? Can you count how many edges? I think above 4 length cycle there, below also 4 length cycle there. 4 plus 4, 8. Right? I think sides 2. This side also sides 2. I think how many? Is it 12? How many edges? 12? Yeah, 12 edges. Yeah, fine. Now listen. Now listen, everyone. Everyone listen. Everyone listen. If it is a planar graph, vertices are 8, edges are 12. There is one formula for planar graph, right? The person who invented that formula is Euler. Euler. Euler, right? Right? You can read whatever you want. It is the Euler formula for planar graph. So V is equal to 8, E is equal to 12. According to Euler, in the planar graph, there is a one formula, that is V plus R is equal to E plus 2. V plus R is equal to E plus 2. What is the V? 8. Right? What is the E? 12. 12 plus 2, how much? 14. So what should be this? This should be 6 or not? Am I right? So R should be 6. R should be 6. What is R? I will clarify. What is R? I will clarify. Remember, R is nothing but regions. Right? Total planar graph will be divided into some regions. Total planar graph. If any graph is a planar graph, right? Total graph will be divided into region. Remember, nothing there. Region is nothing but one room. Region. This is one region. Is nothing but one room. See this one. This is one region. Region R1. See this one. I think closed one. This closed one. A, B, and A. Right? A, E, F, B. This is one region. Now see this one. This is one region. R2. That closed box. That closed cycle. That cycle is nothing but one region. This is one region. This is one more region. This is one more region. Can you help me? Until now, how many regions? Totally 6 regions required. Until now, how many regions? That closed cycle is nothing but a region. Something like rooms. If any graph is a planar graph, then the graph will be divided into some regions. Total, how many regions came till now? 5. Remember. Outside also one region. Outside one region. Can anyone help me now? Outside region. Can you say boundaries? Outside region. Can you say boundaries? I think all those edges. All those edges, they are the boundaries. Means what are the edges you can see? Listen, what are the edges you can see? Those are nothing but your boundaries. So if at all R6 will see like that, one edge is able to see, H to D, right? One more edge is from D to C, one more edge from C to G, one more edge from G to H, right? So whatever edges I am able to see, they are my boundaries. Totally 6 regions. Remember, any planar graph which contain V vertices and E edges and R regions, according to Euler, this formula should be satisfied. V plus R is equal to E plus 2, where R is the number of regions. Right? So see this one. This total plane will be divided into regions. This is one region. See, this person can see this edge. This person can see this edge. See this one. This R1 can see whatever edges he can see, right? Those. This is one region. Now, one interesting answer. R1 can see how many edges? Region R1 can see how many edges? Region R1 can see how many edges? I'm repeating once again. R1 region can see how many edges? 4 or not? That is called degree of a region. Degree of a region R1 is 4. 4 people he can see. Can you help what is the degree of R2? R2 region can see how many edges? R2 region can see how many edges? 1, 2, 3, 4. Next one. R3 region can see how many? R3 region can see how many? 1, 2, 3, 4. Next one. R4 region, what about? Check one time. R4, I think 4. Next one. Degree of R5, I think 4. Next one, interesting answer. Degree of R6. Can you count how many? 4. Is it okay? So this is called region, right? So every region having degree. Every region having degree. Now interesting answer. Can you help me? Interesting answer. This is a edge. Listen, this is a edge. Assume that edge number is 5. Some edge number is 5. This is a edge. It is visible that side also or not? This E5 visible in the R2 also. E5 visible in the R1 also. Remember, one edge will be visible in 2 regions. This side person also can see. That side person also can see. One edge will contribute in 2 regions. Right? That side person also can count. This side person also can count. Bhaiya, are you okay? If you want, you can check. This is the edge number 7. Assume edge number 7, R6 also counting. Edge number 7, R3 also counting, because R3 seeing from this side, R6 seeing from this side. Same edge. There is a wall, right? So outside people also can see, inside person also can see. Remember this story, right? The concept of regions and all will come only for planar graph. If non-planar graph, we don't discuss. A planar graph will divide the given graph into some regions. According to Euler, the formula for the relation between all these people is V plus R is equal to E plus 2. Next, can you listen this? I think all the degrees. Interesting answer. All the degrees. 4 plus 4 plus 4 plus how many times? Interesting answer. 4 plus 4 plus 4 plus how many times? Every region degree 4. I want sum of degrees of region. Can you help in how much it is? 6 people, everyone is 4, which is equal to 2 into number of edges. Can you check? Which is equal to 2 into number of edges. Number of edges how many? 12. 2 into 12, which is going to be 24. Which is also 24. So this is also sum of degrees region theorem. Let me write. Sum of degrees region theorem. That means sigma I is equal to 1 to I is equal to 1 to n. Right? Let me write now. Degree of Ri. R1, I is equal to 1, R1 degree. I is equal to 2, R2 degree. I is equal to 3, R3 degree. Like that, sum of degrees is equal to 2 into E. Check if anyone having any doubt. Sir, I have doubt. You ask me, I will help you. Yeah, sum of degrees of vertices. Sum of degrees of vertices is equal to 2 into E. Similar way, sum of degrees of regions is equal to 2 into E. Fine? Fine? Bhaiya, is it fine? These two things you take care only for a planar. Region means planar graph. Region means planar graph. Region means planar graph. So remember this formula. V plus R is equal to E plus 2. According to Euler, see, Euler is sacrificed his life. Euler sacrificed his life for graph theory. Because if I take the any graph theory, any formula, I am able to see Euler name. Then I Google it out. What is Euler? What he done? He done lot of contribution for the graph theory. Most of the graph theory related problems, he only solved. He only given formulas. He done lot of hard work. I think, in my opinion, he done so many years PhD, right, in graph theory. So many formulas he only invented. So many formulas of graph theory, especially, right, from Euler only. Yeah, can we move further? Can we move further? Can we move further? So remember this formula. Remember this formula. Many times this formula there. In your previous paper, based on this formula, many questions are there. Based on this formula, many questions are there. Please remember. Right. Next, one more small change there. Let me try that also. One more small change. See this. One more small change there. Let's see this also. Yeah, this is, assume that it is a disconnected graph. Assume it is a disconnected graph. It is a graph. But one thing, connected, disconnected doesn't matter. Is it planar? Connected, disconnected doesn't matter. Is it planar? Edge crossing not there. Planar. Edge crossing not there. It is a planar. Everyone know. Yeah, it is a planar graph. Fine. So remember, whatever I am going to say, they will be applicable only for planar graph. Be careful. It is a planar graph. G is a planar graph. I am okay with that. Let's list out vertices how many. Count one by one. Vertices how many? Count all. Vertices how many? 4 plus 3 plus 2 plus 1. I think 9 or 10. Yeah, 4 plus 3, 7. 7 plus 3, 10. Yeah, vertices 10. Can you count edges how many? Edges, I think 4 edges first one, 3 edges second one, outside is 1, totally 8 edges. Yeah, can you count how many regions? Count regions also. It is a very interesting. It's a very interesting regions count. Regions count. Let me count now. R1, R2. Interesting. If you have little doubt also, you can apply that formula. Sir, I have doubts, sir. Sir, I have doubts, sir. See this one. I have doubts, sir. You can apply. V plus R is equal to E plus 2. V is going to be 10. E is going to be 8. 8 plus 2 is going to be 10. I think, right? So can you help me one small line now? What is the R value? V is 10. See this one. V is 10. Everyone listen. V is 10. R is how much? So E value how much? 8. Right? 8 plus 2, 10. 8 plus 2, 10. So it is going to be 10. So can you say R value how much? Can you help in R value 0? R value 0. Am I right or not? So I think now go back and write one small thing. Go back and write one small thing. See this one. The formula whichever I written, right? So I forget to write that statement. See this one. The formula whichever I written, please be careful. Planar graph only, this will work only for planar graph, but connected graph. Connected graph. Planar and connected. If not connected, it don't work. If not connected, it don't work. So because of that reason only, I taken this example. Because of that reason only, I taken this example. Now listen. Now listen one small. Because of it is a connected, because of it is a disconnected, it don't work. Now some people are asking, sir, what should I do? Now you will see this. One more formula there. Disconnected graph, planar graph, but disconnected. There is a one formula. So for that I taken this. Now see this. See everyone. That is only for connected graph, right? Now come here. So it is the R1 region. See this one. It is the R2 region. Everyone listen. R1 region, R2 region. Please be careful. Outside. Outside is one more region. R3. Total outside is one region. Total outside is one region. Can you help me now? In the R3 region, how many people you can see? Interesting answer. Interesting answer. In R3 region, how many people you can see? In R3 region, how many people you can see? See this one. I think R3 can see this edge. 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 R3 can see this one. All outside people you can see. All outside people you can see. All outside people. Let me check one small line. Sum of degrees region. Will it work or not? Check. Sum of degrees of region. Planar graph. Sum of degrees of region. Will it work or not? Let me check. R1 is 4. Okay. R1 4. What is the R2? R2 3. What about R3? R1 4. R2 3. What about R3? Can you count all? 4 people for first part, 3 people for the second part. For the H2I, I think 2. I think 4 plus 3, 7, 7 plus 2. How much? 9. Yeah, can we add all of them? 9 plus 3, 12. 12 plus 4, 16. Right? 2 into 8, 16. Am I right? Am I right? Sum of degrees of region theorem. It will work. Right? Now come here now. Euler, right? Euler formula don't work for this. Euler formula only for connected one. Only for connected one. So remember. So 3 regions. Now last question I want to ask you. R1 degree. Last question I want to ask you. Someone is saying 9 how? Yeah, once again I'm repeating. R1 degree. Give answer. R1 degree 4. See, very simple. What edges you can see? What edges you can see? R1 4. I am very happy. R2. R1 degree 4. I am very happy. R2 degree 3, that is also I am very happy. Now see the answer. R3, everyone listen, R3. Everyone listen, R3. What edges he can see? Listen, what edges he can see from here? He can see this right outside of this wall. He can see this also. Outside of this wall, he can roam. He cannot go inside the room. He cannot go from outside without opening any door. What walls he can see? He can see this. He can see this. He can see this. He can see this side. 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 Total count. Total how many dots are they? 4 plus 3 plus 2. Remember, right? If you take one edge, 2 degrees will come. That side 1 degree, this side 1 degree. Take any edge. See this one. From this side 1 degree counted. From this side 1 degree counted. He is counting this. He is counting this. Every edge 2 degrees will come. Every edge 2 degrees will come. Please careful. Yeah. Now, are you comfortable till now? Are you comfortable till now? If anything is troubling you, that is a new point. See, new points only will trouble you. Yeah. Try to understand new points only. I also learn like this only. Oh, new thing. So in one of the class, unknowingly something happened. Oh, new thing. Okay, fine. So after class over, I used to see what is this, why it came. Everyone, right? Whenever new thing will come, don't cry. If you have this kind of habit, new thing crying, you never grow in life. New thing crying. You have this habit of new thing crying, you never grow in life. Arey, why are you crying for new thing? Why are you crying? Everyone will die. At the end of the day, everyone will die. Just to do best and die. If sir, I will be so scared, I will be there in my house. Anyhow, you will die. Sir, I will go, I will roam outside, I will enjoy and all. Anyhow, you will die, man. So do good things. Make mama, papa proud. Don't scare for small thing. Don't scare for small. What will happen, yeah? What will happen? Right? More than that, people may say fail. What fail? At the end of the day, fail or pass, you have to eat this much food. Fail also, mama will keep food. Pass also, mama will keep food. What is fail? What is pass? Whatever you want to do. You want to get the good GATE rank. Get the good GATE rank. How? Complete the syllabus. If I don't get GATE rank, what will happen? At the end of the day, you will eat food only. 3 times you will eat. Anyhow, mama, papa will keep, whether you get the rank or not. You want to make sure your family will go one more position forward. One more position forward you want to make. Right? Try your level best without getting fear. Do good things. Don't do the bad things. Do good things. Right? You want some recognition. When you do nice thing, people will recognize. Suppose isn't that some people saying that, sir, I want to earn money. Somehow I will earn. Okay, let us assume somehow you earn money. You done bank robbery and you got crores and crores. 20 crore you got. Bank robbery you done. 20 crore you done. Can you say to anyone proudly? You got money, 20 crore. Can anyone say proudly? Even your family member you cannot say. What is the use of that kind of money? Earn 10 rupees also proudly. By doing this I got. Right? Do anything which can give the nice name, nice thing to your family. Right? So final conclusion I want to say to you. Everyone please take care of this. Everyone please take care. New things don't afraid. Nothing will happen. If at all something new, learn it. Really you don't have any idea. Right? Learn it. Seriously troubling you. I think revise 1 or 2 times. 1 or 2 times revise. What will happen? More than this, what will happen? Right? Fine. So if you want to win the games, right, any new thing will come. Suppose something nice thing happened. Let us assume you tried some A. You tried some A. Unfortunately, answer is, you thought answer A. Unfortunately, answer is B. Instead of crying, say like this one, oh, like this also can come. Okay. You thought answer A, but unfortunately answer B. Oh, a B. I thought A is the answer. It's a B. Oh, like this also can happen. Okay. Okay. Still you have doubt. Revise one paragraph. Revise that area, one small paragraph. If you have doubt, you can post in the group. Like that, you can. No need to F-write. No need to F-write. See, whatever possible, GATE exam is on second month, Feb month. Until last minute, do whatever you want. This subject, do whatever you feel. Complete all the things, complete until this date. Until second month, second month entrance, every subject should be over and practice also over. No need to afraid in between. So this subject, A subject, B subject, C subject, D subject, everything you have to do. No, right? No emotions, nothing. Right. So my final request to everyone, my final request is, right, my final request, without afraid, right, if anything new coming, learn, right, your target is completing syllabus and doing the practice. Now come back, someone is saying that, can you go to disconnected graph one time? I'm going. Now listen, I'm going. Vertices are 10. So again I'm repeating now, don't afraid for the failures. If any new thing will come, please smile it and learn. New thing will come, please smile it and learn. Nothing will happen. Nothing will happen until last minute try. Some people are so scared. Can I complete syllabus or not? If you really scared, can I complete syllabus or not? Spend more time. Spend more time. Why are you crying? Right? Some students are saying, sir, I am really afraid of, can I complete syllabus or not? Are you really afraid of? Yes. You really like GATE? Yes. Then spend more time. Whatever unnecessarily you are wasting time, just to minimize that unnecessary thing, right? Increase the number of hours in the GATE. Like that, if you have to utilize everything in the positive way, right? Okay, I think I said more. Can you come here? Vertices are 10, edges are 8. Vertices are 10, edges are 8. Can you help in how many regions? How many regions? How many regions? How many? 6 regions. Regions, yaar. How many regions? 3. 3 regions. Now, interesting answer. How many components? See, remember, connected graph. One connected graph is known as one component. So this is one component. Because of the disconnected, so many components are there. It is one component. See, connected graph, right? A connected subgraph is a component. So this is one connected component. This is one connected subgraph. Like that, 4 components are there. Right? Now see the formula. This also you are only created. V plus R is equal to, actually previously, V plus R is equal to E plus 2. This is the previous formula. Now this is for connected. Now see disconnected. V plus R is equal to E plus. Remove these two. In these two place, right? K plus 1. V plus R is equal to E plus K plus 1. Let's check. What is V? 10. Right? What is E? 8. What is R? 3. What is K? 4. Right? 1. Am I right? Check. In the place of 2, because of it is disconnected, components will come plus 1. In the place of 2, components will come, k components, plus 1. Original one may be 1. Original one may be 1, right? Like that. Just remove 2, replace 2 by k plus 1. Replace 2 by k plus 1. This is for disconnected graph. This is for disconnected graph. Now can you help me one small line? Can you help me one small line now? Very, very interesting line. Very, very interesting line. Very, very interesting line. Can you help me now? Disconnected graph. Disconnected graph. Suppose assume graph is connected. How many components are there? Suppose assume graph is connected. How many components are there? One component or not? Replace k by 1. Replace k by 1. 1 plus 1 becomes 2. E will come. E will come. So below 1 will work for anyone. Below 1 will work for connected also, disconnected also. But above 1 is clearly for connected. Above 1 is clearly for connected. Below 1, connected also will work. Disconnected also will work. Connected also, disconnected also. Because keep the k value 1. This is only for connected. Replace 2 by k plus 1. Suppose if it is a connected, keep the k value 1. It became 2. Above formula will come. Again came. Yeah. Bhagavad Gita came. Atul written Bhagavad Gita. Can you return? Can you read? Can you read his Bhagavad Gita one time? Today morning we missed out that Bhagavad Gita. Today morning we missed out that Bhagavad Gita. Sir, what is the intuition behind this formula? Like how Euler sir, okay. Euler sir, he kept name also. He respected Euler. How Euler sir reached to this formula? And still yet there is no graph which can disprove this formula. There is a proof also, Atul, there is a proof also. There are, I think that is the meaning of PhD, right? If I give 5 years time, right? Definitely you also will do nice PhD. PhDs will happen like this only. Sometimes PhDs are 3 years. Sometimes PhDs are 5 years. Because if you really like it, you will do it. If you really like it, you will do it. Someone is saying, what is the degree of region? Listen, what is the degree of region? Arey, bhaiya, how many regions? So Jaya asking so smoothly one nice line. Can you help in how many regions? How many regions are? 3. How HI is one region? H2I is one region. Who said to you? Right? HI is the part of the region R3. Region R3 contain H also, I also, J also. Are you getting? HI is part of one region. HI and J also. That is the reason R3 degree is 9. R3 degree 9. Fine. Fine. Yeah, very good doubt. Atul will become Euler one day. Yeah, I think, yeah, the patience what Atul is having, right, to type that much nice sentence, right? Really. So if you really like, right, anyone like really research, they can go. That's the purpose of MTech. Don't go PhD directly. Don't go PhD directly. Do MTech first. While doing MTech, if you really like it, you can go for PhD. My roommate is there in IIT Bombay. My roommate is there, right? He got all India rank maybe 2. He got all India rank 2, right? So he studied with me in IIT Bombay. He got 2nd rank. So afterwards in IIT Bombay, he got gold medal also, right? So he really like it. He really like studying. He really like proving theorems, right? He really like not teaching, right? He really like proving theorems. He really like research in some domains, right? So then what he done is, so he wherever whatever, right, whatever MTech is doing, that MTech guide is so happy. So that MTech guide he said that, right, can you do PhD under me? Can you do PhD under me while doing MTech itself? Right? In the second year, that guide is asked him, do you want to do PhD? Do you want to do PhD under me on the same problem? I am working on this problem from the last 20 years. You just started now. I really impressed with your work. Do you want to do PhD? He said, yes, I want to do PhD. Then guide said that I will give your PhD degree within 2 years only. Can we start PhD? He said, yes. After MTech is over, he got MTech degree. So afterwards he started PhD. We all came out. So he continued the PhD with him only. So within 2 years he got PhD. Within 2 years he got PhD because they understand the problem, right? They both are really cooperated each other, right? Finally PhD is over within 2 years. Afterwards he went to MIT. Afterwards he went to MIT for postdoctoral. After in IIT, right, PhD is over. MTech and PhD is over within 4 years. Then he went to postdoctoral in MIT. Right, after completion of the postdoctoral, right, now he is the faculty in Stanford. Now he is the faculty in Stanford. If you really want, first of all, you should like it. Right? You should like it first. You should like it. If you don't like it, there is no point of going. If you like it, please go. If you like it, please go. Right? So, but don't take a strained decision at a time. Go step by step. First, you done MTech. You done MTech. After MTech, who knows? After MTech is over, you may not like teaching. Sorry, you may not like research. You may not like PhD. So go slowly. One of my student is there. Listen. One of my student is there. Everyone listen. One of my student is there. That person got, right, directly PhD. One of my student is there. That person got directly PhD. In one of the IIT, directly that person got PhD. 5 years PhD program event. Yeah, she actually, Ayushi, her name is Ayushi. So she went to one of the IIT for the, based on the GATE score, she got in one of the IIT PhD. So she went there. It is a 5 years course. After 2 years are over, right? She is not happy. She got to know this, right, that project is not moving further. So she dropped it. So finally, in the PhD, in the middle you came, you don't achieve anything. No MTech degree also. My request to all of you, if you really want to go to PhD, don't go PhD. First go MTech. After MTech is over, if you think that job is your hope, you like job, then go to job. Suppose you want to still further continue, go to the PhD. So like that. Okay, can we come here? Can we come here? Can we come here? Because of Atul only these all things happened. Because of Atul only all these things are happened. Are you okay here? Are you okay here? Can we move next? Otherwise it never be over. Otherwise it never over. It never over. It never over. Sir, you like research? No, I like teaching. That is the reason I am able to teach three classes. That is the reason I am able to teach 3 classes. I like teaching. Right now, can we move next? Can we move next? Hello. Oh, can we move next? Someone is saying, can you say the reason why you limit to 6 subjects? Very simple. So, right, if I keep on teaching all, right, what about doubts? I only should give every subject doubts. Everyone depend on me. This doubt, that doubt, and all. I thought it will create a lot of problems. Right? Only, right? So if one person teaching all, I don't think so. Suppose I got somewhere health issue. I got, right? Everyone eagerly waiting for me. So I don't want to spoil students' life. Right? Based on one person, no system can work. Based on one person, no system can work. It will create so many complications. Right? For my greatness, I cannot spoil student life. Can we move next? Bhaiya, say yaar. Can we go next? Can we go next? Yeah, fine, perfect. Fine. Thank you so much. Thank you. Let's go to next one. Remember, can you help me now? For planar graph, how many formulas? Planar graph, how many formulas? For a planar graph, how many formulas? This is the normal. Sum of degrees regions theorem. Sum of degrees region theorem. That is the one. Majorly these two. It is the two. It is a three. Please careful. By hearting blindly, very difficult. You may forget. By hearting blindly, you may forget. So meaningfully study. That's it. Keep on revise. Now I am giving one problem. Can you try this? Yeah, take this. Example. Yeah, you have to find out which are planar. Option A. 1, 2, 3, 4, 5, and 6. Go to the next one. B, A, B, C, D, E, F, option C. Option D. Yeah. So can you go ahead? Which are planar? Yeah, someone is saying, sir, sum of degrees formula applicable for both planar connected and planar disconnected graph. Check one time. Yeah, I think it will work. We verified also. We verified also. It will work for all. This is only, see this one, this is only separate. See, connected components. Oh, this is for disconnected and connected also. Because here nothing there, no K, nothing. See, here no K means connected. But here for everyone it will work. But it should be a planar. Now, can you concentrate this and finish it off? Yeah, can I give answer? Can I give answer? Yeah. What about first one? What about first one? Bhaiya, what about first one? First one is planar? No. Right outside, I think some crossing is there. Can you see second one? Second one, I think happily you can bring outside. This person you can bring outside. This person you can bring outside. It's fine now. I think no crossing. What about option C? Wherever crossing, I think this is the crossing. Bring outside. Yeah, here I think this is one person. So I done this. I think I can remove this. Is it okay now? Any crossing still? No problem, right? No problem, right? I think BCD. I think BCD. Right? I think BCD. Yeah. Now move to next. I think we done enough problems. Right? Remember, see this one. Many problems are there. Many problems are there based on this formula. Many problems are there based on this formula. Please careful. If you see the previous paper, please careful. There are PYQs are there in your app. PYQs are there. Please see them. Please go to corresponding subject. 20 years PYQ, all are there. All are there. Please completed subject at least to do that. Completed subjects, please do that. If any subject you completed, right? So 20 years PYQs all are there, right? Please go through it one time. As soon as you complete, please check. Now come to the next one. Because of you are really okay. Come to the next one. A, B, C, D. Listen everyone. These all are even degree. Observe clearly. Observe clearly. Every vertex degree is even as of now. Every vertex degree is even as of now. Every vertex degree 0. Every vertex degree 0. Right? Every vertex degree is even as of now. Yeah, fine. Now listen. Now listen everyone now. Every vertex degree is even as of now. Every vertex degree is even as of now. Now listen. See correctly. See correctly. This C, I kept odd degree. Can you help me now? One person got odd degree means another person also will get odd degree or not? One person became odd degree means one more also will come. Alone one person cannot come. Initially all are even degree. Suppose you tried one person odd degree, definitely one more person also will come. So what I want to say is number of vertices with odd degree is always even. Number of vertices with odd degree is always even. If you want, you can check. One more thing you see. One more thing you see. A, B, C, D. This is already, these two are odd. This also odd. See. Every time odd number of people are coming, two people coming. Two people are coming with odd degree. Two people are coming with odd degree. Please careful. Now, what about this? Let's see. A, B, C, D. You try whatever way you want. You try whatever way you want. See this one. Number of vertices with odd degree. You cannot make odd. Number of vertices with odd degree is always even. So let's try for odd. See, I want to keep this as only odd degree. Remaining all even degree. Let's see. I want to keep this as odd degree. This as odd degree. I will keep here. See, this became even, but this became odd. Right? Let me try this. Let me try this. This became, right? This became odd. This also became odd. So from this conclusion, the number of vertices with odd degree is always even. Yeah, be careful. Remember simple graph. Remember simple graph. We don't talk anything about multigraph. The number of vertices with odd degree is always even. Remember this note. Yeah, can we move to next? Can we move to next? Yeah, last slide, please. Yeah, I will show that. So see this. The number of vertices with odd degree. The number of vertices with odd degree is always even. Initially, all are even. If you keep one edge, two people became odd. If you keep one more, four people became odd, which is even. The number of vertices with odd degree is always even. Okay, fine. I think you got this line. Can we move to next? Remember this. Remember, see, for everything proof is there. At anywhere, if you have any doubt, if you have at anywhere any doubt, I think if you Google it out mostly, you will get the proof also. If you really want proof, you will get the proof also. But examination point of view, proof not required. Anywhere you have doubt, anywhere if you have doubt, right? Please let me know. Come to the next. One more small thing there. One more small thing there. Everyone observe. One more small thing there. Everyone observe. See this. See correctly. One more example. Yeah. Simple graph contain. Observe properly. Simple graph contain. Simple graph contain 7 vertices. See the one more way of asking the question. See how they will ask. Simple graph contains 7 vertices. Those are assume A, B, C, D, E, F, G, A, B, C, D, E, F, G. 7 people check. Simple graph contains 7 vertices A, B, C, D, E, F, G. And their degree. And their degree. Let me write 5, 5, 3, 3, 2, 2, 2. Can you see? Are they 5? Are they 7? Simple graph contains 7 vertices A, B, C, D, E, F, G, and their degrees 5, 5, 3, 3, 2, 2, 2. Is it true or false? This kind of simple graph possible or not? Is it possible? This kind of simple graph, is it possible? This is also called degree sequence. This is also called degree sequence. For a simple graph, listen, a graph which contains 7 vertices where degrees are like this. I'm repeating once again. A graph which contains 7 vertices, degrees are like this. Right? Next one. The question what they are asking is it simple graph? Simple graph possible or not? Simple graph with 7 vertices A to G and their respective degrees are like this. Is it possible? Is it possible? So we have to give the right some nice one. Like that, what he will do is, listen, what he will do is, if it is possible, people used to say that this degree sequence, right? Suppose assume that for this degree sequence, simple graph, right? You can draw, assume. Then this is called as graphic. Simple graph possible. Graphic means we can draw the graph. We can draw the simple graph. That is the meaning of this. So what they will do is they will give one problem like this. See this one. They will give which one of the following is graphic. Another way of asking same question. Which one of the following degree sequence simple graph possible? For the given degree sequence, simple graph is possible, then it is graphic. Otherwise, it is not graphic. I'm repeating once again. For the given degree sequence, simple graph is possible, then it is called graphic. Otherwise, it is not graphic. The ways of asking this question is they will give like this one. Which one of the following degree sequence simple graph possible? Another way of asking, which one of the following degree sequence is graphic? Right? Now I will try to this degree sequence. Simple graph is possible or not? I will try. Can you see the procedure? Simple graph contains 7 vertices and their respective degree sequence is given. Now he is asking, is it possible? Right? For the given degree sequence, simple graph is possible. If it is possible, say graphic. If not possible, say not graphic. Right? I will try. See the procedure. See the procedure one time. Everyone observe. Everyone observe how to check simple graph is possible or not. How to check it? Let me see. Can I start? Can I start? Can I start? Yeah, simplest way. Listen, simplest way. Before going to start, simplest way. Before going to start, simplest way is, can you help me now? How many vertices with odd degree? Simplest way. Check the minimal things. So the time will not waste. How many vertices with odd degree? Total 7 people, okay. How many vertices with odd degree? 1, 2, 3, 4. I think 4 people with odd degree. Of course, we know number of vertices with odd degree in the simple graph is going to be E, right? What is the answer? Even. Number of vertices with odd degree in the simple graph is going to be even. Okay, that is satisfied. And one more thing I want to ask you. Can you see sum of all degrees? How much? Can you see sum of all degrees? Count. 5 plus 5, 10. 10 plus 6 is 16. 16 plus 4 is 20. 20 plus 2 is 22. 22. Right? 22. Can you help me now? Can I write 22? Can I write 22? 2 into E means 2 into 11. Remember, sum of degrees is always even. Sum of degrees is always even because it's the 2 into E. Anything which you can write 2 into something, right? Definitely it is an even number. So I think sum of degrees are 22, which is also even number. That is also correct. Sum of degrees working. Number of vertices with odd degree is even. That is also working. And one more thing. These are preliminary things. If you don't want to do any procedure, just check minimal thing. And one more interesting answer. 7 vertices are there. What is the maximum degree of any vertex possible? 7 vertices are there. What is the maximum degree of any vertex possible? Maximum. 6 or not? Yeah, here 5 there. It's okay, possible. But one thing, 7 vertices are there. Maximum degree of any vertex cannot be a 7. Please be careful. Sometimes 7 vertices, one of the person degree is 7. How it is possible? Maximum is 6. What is the meaning? Either 6 or less. Okay, less okay. I think all preliminary things I done, right? I am unable to find any mistake here. Let's see the one more good procedure. One more good procedure is there. I will try. See this one. I done preliminary checking. If at all you are lucky, preliminary checking itself, you can close it. What are the one preliminary checking? Sum of degrees should be even. Sum of degrees should be even. That is the one thing. Number of vertices with odd degree is always even. Next one. Simple graph, 7 vertices. Maximum degree of any person is 6 only. All small thing everyone knows. Those only I done. Listen, if you want to check like that, that is a one way. But right, if you think that those many things we will check, sir, I may forget. There is a one simple procedure. Just follow. You can easily do it. See the procedure. So what you do is all the degree sequences, whatever they given, keep all the right degree sequences in the sorted order. That is also decreasing order. So let's see this one. All the degree sequence, whatever is given, keep in the sorted order. That is also descending order. Means larger one first. 5, 5, 3, 3. Keep in the sorted order. Okay, I kept. That is the first step. Take the degree sequence, arrange them in the sorted order. That is also descending order. Okay, I done. Now listen. Its degree is 5. Everyone listen. First person degree is 5. So what you do is, see this one. First person degree is 5. So what you do is, everyone observe. First person degree is 5. Then what you do is, every person decrement 1. 5 people is right. 5 people, right? After him 5 people. Decrement the degree by 1. It became 2. It became 1. It became 1. Is it okay? One person having degree 5 means is associated with 5 people. For all the 5 people, decrement 1, 1, 1. Now, then the story is because of everyone, right? Everyone, to him, to other people, edge there. For all of them, you decrease to him also 5. Then it became 0. Then it became 4, 2, 2, 1, 1, and 2. This person as it is, I copied. Because of everyone you deleted, of course, right? All his degrees he lost. Now, whatever you got, again keep in the sorted order. Again keep in the sorted order, in the decreasing order. First 4 will come, next 2, next 2, next 2, next 1, next 1, 0. Just you kept all of them in the again sorted order, decreasing order. Continue the same story. Again is having 4. 4 people decrement 1. Then it became 1. Then it became 1. Then it became 1. Then it became 0. 4 people only. Then because of everyone you removed, he also became 0. Now the answer, if you see 0, 1, 1, 1, 0, 1, 0. Now again sort. Again sort him. Again sorting. Then what is the answer? If you sort again, then what happened is it will become, right? Sort them. I think triple one. One more one from here. Remaining is triple zero. Now see the answer. Now see the answer. Anywhere you want to stop, you can stop. See, after first step is over, if you want to stop, stop. After second step is over, if you want to stop, stop. See this one. After this step is over, if you want to stop, you can stop. At anywhere, if you want to stop, stop. Right? If you want to continue, also continue until all will become zero. If you want to continue, also continue until all will become zero. Some people are asking, sir, how to continue? If you want, you can stop. Some people are asking, how to stop, sir? See, sir, already something there. How can you stop? Can anyone help me? To this, can you draw simple graph? Listen this. To this one, can you draw simple graph? Totally 7 people. Can you draw, right? Totally 7 people. Can you draw simple graph? Yes. Is it possible? At anywhere, if you feel I can draw, at anywhere, if you think I can draw, I'm repeating once again. At anywhere, if you think I can draw the diagram, I can draw the diagram, stop it. Can you help me now? 4 ones. Is it 4 ones available? Is it 4 ones are available in the final answer? Final answer 4 ones. I think 4 people degree 1. 4 people degree 1. You can draw whatever way you like. You can draw whatever way. At anywhere, if you felt I can draw the diagram. See, bigger one I may not able to draw. Bigger one I am unable to draw. So what I am doing is I am doing stepwise. What is the answer? I think one person having degree 5, then inform to 5 people, right? To me 5 degree means you all the people are having, right, 1 to me. So everyone remove 1 because I am going out. This 5 is saying that I am going out. My degree 5 people are there. Everyone decrement by 1. All the 5 people are decremented 1. Then he went out. See, his value became 0. All the people are decremented. Now whoever is available, again sort. Again this 4 is saying that I am also going outside. My degree is 4. Means 4 people are associated with me. Right? Those all people first remove. Right? After removing, I am also going. Continue this until zeros will come. Now some people are asking, sir, if diagram is possible, I can stop. Suppose assume I have doubt. Continue this procedure. Some people are asking, sir, how to continue? So you sorted. Now see, 1 1 1 1 0 0 0. Now see, I think after keeping the sorted order, decreasing order, this one will say next one person decrement 1. It became 0. Then he will also became 0. Now see the modified one. Once again sort. It became 1 1 0 0 0, right? Like this. Now again this one will say that next one person decrement degree by 1. It is a 0. It is also 0. Lastly all zeros came. If all zeros came, stop. Indication that everyone you neglected, everyone you removed properly. So finally all zeros came, stop. If all zeros came, stop. That means, right, for the given degree sequence, simple graph is possible. So it is a graphic. Or simple graph is possible. At anywhere, if you think that I can draw the diagram, stop and draw the diagram. If you think that diagram is not possible by me, then go like this. Go this procedure. Go this procedure. Yeah, I think I'm thinking that little bit you got. Johan saying, sir, what is the logic doing the above steps? Can you please explain? Okay, again, take the one more problem. I think you got some idea. So I will give now one problem. Can you check yourself? Can you check yourself? Right down. Check following, right? Following sequences. Let me write now. Let me write. Yeah. Graphic. Verify following degree sequences are graphic or not. Option A. Take it. Option A. 1 1 1 1 1. How many people? I think 6 people. 6 ones. B. Option B. 6 twos. Option C, 333, 1, 0, 0. Option D, 3, 2, 1, 1, 1, 0. Now see this one. For all these four people, to which graph simple graph is possible? If listen everyone now, Johan, if possible, you can draw simple graph. Option A, if you think that option A, sir, option A, right? I can draw for the given degree sequence, I can draw the graph. You can draw. Suppose if you cannot draw that procedure, whatever I explained, I will explain again. Can you help me? Number of vertices with odd degree, is it always even or not? Number of vertices with odd degree is always even or not? Number of vertices with odd degree is always even or not? It's always even. But in the option A, how many people with odd degree? In the option A, how many people with odd degree? 6 people. Even, I think no problem. Even, no problem. Next one, sum of degrees how much? 6. That is also no problem. And one more, 6 people are there. What is the maximum degree possible? 5. I think 5 or less than 5. That is also okay. It look like possible. Look like possible. You please check properly. Can you help me? Is it possible? I think directly I can say also. Can you see this one? A, B, C. Listen, D, E, F. 6 people, D, E, F. I can write like this. Is it possible? I can write like this. Is it possible? If you can draw simple graph for the given degree sequence, it is a graphic. Possible? Everyone degree 1. Possible? If you can draw directly, I don't have any problem. So option A, possible or not? Option A, possible or not? If you think right, just verify yourself. Manually, you try first. See, don't do any procedure blindly. Otherwise, a lot of time will take. If you keep on doing blindly, a lot of time it will take. If you think possible, do directly. If you think some dilemma, whatever procedure I said, you can do it, right? So I think option A possible. Okay. What about option B? Member of vertices with odd degree even. Okay. Option B possible. Let's try this. Degree 2. It is also degree 2. Possible. Everyone to possible. Everyone to possible. See, if you can do manually, no objection at all. If you think some trouble is there, the procedure, whatever I said, you can apply. Worst case, you can apply that procedure. I think B also possible. Everyone to. Every person degree 2. Possible. Yeah. Some people are asking, what about option 3, sir? Sir, what about option C? What about option C? Let's check preliminary thing. Let's see the preliminary things. Check the preliminary things first. Worst case, we can apply that procedure. Option C possible or not? Option C possible or not? Option C possible or not? So if anyone thinking that possible, See, let me do. So if you can do diagram directly, well and good. If you have little doubt also, you can apply this method. See the method? See the method now. See the method. See, my degree 3 means, listen, my degree 3 means from me to 3 people. Edge there or not there? My degree 3 means from me to 3 more people. Edge there or not there? Johan, please give answer. Number of vertices with odd degree is even. Yeah, that is working. Next one. Sum of degrees is even. Is it right? Sum of degrees even. That is also right. Right? We will see now. They are the preliminary checking, but that is not final. They are preliminary checking. That is not final. Can you see the Johan procedure? Can you see the Johan? Everyone see. This is the one of the theorem. Listen properly. Simple graph possible or not? We are checking. See how it is. See this one. See how it is. My degree 3 means to me there are 3 more people are there. Where edge there? So let us enter my degree 3. So from me to Johan 1 degree. From me to Shakir 1 more degree. From me to Jaya 1 more degree. So what I will say is, so I am going out. I am going out of the graph. My degree is 3. I am going. So those people to whom adjacent to me, they all will remove 1, 1, 1. I am going. My degree 3, I am going. So my degree 3 going. So all the people remove. So that is the procedure. See this one. First to sort them. Already sorted. Now see the first step. So 3, 3, 3, 1, 0, 0. This person saying that I am going outside. My degree 3 means 3 people are adjacent to me. So what I will do is I am going. So next 3 people decrement 1 because you kept in the decreasing order, right? All the best people are there in the initial phases. So all the 3 people inform. Next 3 people decrement 1, decrement 1, decrement 1, 0. Remaining people keep as it is. Now he can go happily outside. Then what is the answer? It became 0, 2, 2, 0, 0, 0. That is the first round. Now once again sort. One round over, one person out. See, he went out. He simply said that I am going out because all my burden is removed. I am going out. Now, whoever is available, sort again. 2, 2, 0, 0, 0, totally 5. If you want, you can keep this person also last because anyhow he is 0. Whether you keep or not doesn't matter. Now see the answer. This person saying that, listen, the interesting answer. This person saying that I am going outside. To me, 2 people are adjacent. Those all people keep 1, 1 out. So what is the answer? Next to 2 people keep 1, 1 out. He is keeping 1 out. Listen, he is keeping 1 out, but he is saying I cannot. He is saying I cannot. I think you can stop it. Because he is saying that I am going out. Next to 2 people should decrement 1, but he is 1. How he is decremented? So what I mean to say is this kind of thing not possible at all. 2, 2, 4 zeros. No way. If you want, you can check the diagram. A, B, C, D, E, F. Try whatever way you want. You want 2 people exactly degree 2. 2 people exactly degree 2. How it is possible? And one more unfortunate thing. Can you see the unfortunate thing? Number of vertices with odd degree. Is there any odd degree? Yeah, odd degree not there. That's okay. Can you see this one? Can you arrange to me 2 vertices with degree 2? 2 vertices with degree 2. Is it possible? No way. Not possible. Fine. Then it is not a simple graph. There is no way. 2 vertices with degree 2. Not possible. If anyone says, sir, here itself I can do. Here itself, if you can draw, you check. See, because checking the bigger one difficult. The best idea is 1 by 1 phase. Remove 1 person. Maximum. Suppose that I have 5 degree. I will inform to 5 people. 5 people I will inform. Please remove 1, 1, 1. I am going out. So everyone removed their part. So I went out. Now graph became smaller because one person out. This person is out. Now in the remaining one, can you try? In the remaining one, you can try. So I think it is not possible. Now I think option C not possible. Right? So some people are asking, how can you say option A possible? Directly I draw option A, directly possible I done. If you want, you can do this method also. Can you see this one? Option A, you can do this method also. See the answer. This person will inform, I am going outside. After me, whoever there, one person make decrement by 1. He became 0. Because of he is going out, now he will also become 0. Now again sort it. If you sort now, it became 1 1 1 1, 4 2 zeros outside. Again he will say same, I am going outside. Next one person decrement by 1. He became 0. Then I think he is also going outside, he is 0. Now left out people once again sort 1 1 0 0 0 0. Again same, he is saying I am going outside. Right? After me one person decrement by 1, it is 0. It is again 0. Find all zeros. All zeros means happily you can stop. Right? It is a graphic. Option A possible. If you want to draw manually diagram, you can draw. Otherwise, you can check like this also. Let's see the option B also, only for namesake. Can you see the option B also? 2 2 2 2 2 2. This person saying that I am going outside. After me, next to 2 people, because I am 2. Next to 2 people, decrement by 1. It became 1. It became 1. Now it became 0. Whatever is there, short it. So what is the answer? You have to keep in the decreasing order, so that best people always on the first place. So what is the answer? I think out of 6 people, 1 person 0, 2 people became 1, 3 people became 222. So let me write 222 1 1 0. Now again he will say I am going outside. Next 2 people decrement by 1. He became 1. He became 1. He became 0. Now if you sort once again, I think what is the answer? I think 4 ones are there. 4 ones are there, 0 0. 2 people are out. Now I think 4 ones, I think we may be done in the above one. See, 4 ones possible, further possible. So I think you can stop and say that, right? Option B also graphic, because from now onwards it's a copy of the previous problem. So option B also graphic. Option C we are already tried. Now go to the option D. See the option D now. Everyone listen, option D. This person will say that next 3 people decrement by 1. Next 3 people decrement by 1. Okay, it became 0. It became 0. Now sort it. It became 0 now. Now if you sort it, right? I think here 1 there, here 1 there. Remaining all are, I think 4 zeros. 1 1 4 zeros. Now I think this one will inform to next person decrement by 1. 0. It is 0. Lastly became 6 zeros. Fine, it is also possible. Is it okay now? If anyone having small doubt, you can draw the diagram. You can draw the diagram also. Check diagram also you can draw. If you try properly, diagram possible. You no need to listen. You no need to write the entire diagram. Listen, you no need to write the entire diagram at a time. You can go stepwise also. At least can you draw for this? Interesting answer. Interesting answer. At least can you draw for this? If you can do part of it also, total also you can do. See this one, A, B, C, D. At least try to do for part. Try to do for part. I think 1 1 required. 1 1 required. This is 1 1. This is 1 1. Yeah, you may say that 1 1, that is fine now. 1 1. What about the actual diagram? You can try like this. You can try a little bit. 3 2 1 1, right? 3 2 1 1. Given problem is 3 2 1 1. Can you check how it is possible? Is it fine now? Check. 3 2 1 1, 1. Possible? Possible? If you can do part also, you can add B4. Step you add, see, previously, see how you are doing, right? How you are doing, see this one. Everyone you are decrementing 1, you are deleting this. Now you can do backward. What is the answer? Everyone you can keep the degree, right? Like that you can do. Anyhow, this is the procedure. So they will give degree sequences. They will ask you, is simple graph is possible or not? If you want, you can do preliminary checking so that you can stop immediately. Right? Preliminary checking you can do. No, sir, I don't want to waste time. Then you can go directly like this. One. Now I will ask you one small question. Is it possible or not? Let me try. Is it possible? See this one. Is it possible? Let me try. Yeah. Is it possible? Total, I think 7 vertices. Can you help me now? If the graph contains 7 vertices, yeah, let me see. See, I think Atul, if you don't do preliminary checking means all the things, whatever you studied in the graph theory, they are preliminary things. Preliminary things I cannot list out also because there are many things. Now let me check one by one. Preliminary things, whatever you knows. Let me check. 7 vertices are there. What is the maximum degree possible? These are called preliminary things. Preliminary things means whatever you studied till now in the graph theory. Can you help me? Interesting answer. 7 vertices are there. What is the maximum degree possible? 7 vertices are there. What is the maximum degree possible? Interesting answer. 7 vertices are there. What is the maximum degree possible? 6. Right? Can you help me now? Degree 6 possible or not? One worst idea. Listen, one worst idea is apply that procedure, whatever I said. Apply the procedure, whatever I said. That's the one way. If you want to apply graph theory, basic knowledge, whatever you have, you can apply also. Can you help me now? Number of vertices are 7. Maximum degree possible for any vertex is 6. Listen everyone now. Maximum degree possible for any vertex is 6. You only say to this person maximum degree means he is adjacent to all other person. 1, 2, 3. See this one. 4, 5, 6. Am I right or not? 1% degree 6 means, listen, 1% degree 6 means he is adjacent to all people or not? Totally 7 people. 1% degree 6 means he is adjacent to all people or not? Listen everyone now. He is adjacent to all people. He is also adjacent to all people. There is one more person who is adjacent to all. If that is the case, everyone degree should be minimum 2. Am I right or not? He is adjacent to all people. He is also adjacent to all people. If that is the case, every person degree should be minimum 2. How it is possible? Yeah. Some people still saying that 2 was degree 1 possible. How? 1% degree 6, right? He is adjacent to all. One more person also degree. Let us assume that he is a degree 6. He is also degree 6 assume. What is the answer? He is adjacent to all people. 1, 2, 3, 4, 5. Anything else? 1, 2, 3. Already there, already from A, already 1 there, right? B. So this is also degree 6. So this is also degree 6. So that is also degree 6, right? I think it is a guarantee everyone having minimum degree 2. Everyone having minimum degree 2. So this is, I think here, this is also minimum degree. How it is possible? So that is the meaning of preliminary checking. Whatever graph theory, basic knowledge you have, you can apply that. That is a one story. One more, you know very well. Number of vertices with odd degree is even. You can check it. Number of vertices with odd degree even. It is a odd degree. It is a odd degree. It is a odd degree. Number of vertices with odd degrees, it became how much? Number of vertices with odd degree, it became odd. So you can stop like that also. Suppose it is 2. Suppose it is 2. Assume number of vertices with odd degree is even. 1, 2. Yeah, then it is satisfied. But you only say 2 people are there with maximum degree. How 1 person degree 1 possible? It is not. It is impossible. Right? It is impossible. So Atul, whatever graph theory basics you understood till now, those you can apply one by one. Those you can apply one by one. Instead of applying those many, this theorem is better or not? Instead of applying those many things, this theorem is easy or not? This theorem is going to be easy or not? Instead of applying those many, we don't know which order we have to apply. We don't know how many conditions are there. Based on all those conditions only, this theorem is made. This theorem is made, the proof, what, right? The procedure, whatever I explained, that procedure is made by using all these things. If you think that it is taking some time, you can apply preliminary things. Okay, 7 people. So maximum degree possible for any person is 6 only. Yeah, if at all 1 person 6 means everyone degree 1 guarantee. 2 person 6 means everyone minimum degree 2 guarantee. 3 person 6 means every person minimum degree 3 guarantee. And one more, number of vertices with odd degree even, verify. And one more, sum of degrees are even, verify that also. But based on all of them only, right, this procedure also designed. If you think a lot of time, just have preliminary checking. If you don't want to do also, no problem, right? So only for, can anyone say lastly, to this problem, is it possible or not? Is it graphic? One person is degree 1. Is it graphic or not? Suppose that 1 person degree 1, is it graphic or not? No, right? Because 2 people are there with degree 6 here. Everyone is adjacent to them. Everyone adjacent. It's not a graphic. If you want, you can see that procedure. Can you see that procedure? Can you see this procedure? This person saying that my degree 6, I am going out. Right? After me 6 people. After me 6 people. Decrement by 1. So it became 5. It became 4. It became 3. It became 1. It became 1. It became 0. Now this became 0. Now let me simplify. Can you sort it? What is the answer? 5, 4, 3, 1, 1, 0. This 0 also will come. Right? Now see the answer. Now see the answer. 1 round over. This 5 is saying, I am going out. Right? 5 people, decrement 1, 1. But unfortunate thing is, see the unfortunate thing, 5 people not there. Only 4 there. He is saying that my degree 5 people decrement by 1, but he is saying we have only 4. Here you can stop. It is not possible. He is saying 5 people decrement 1. Not 1 person, 2 person. 5 people decrement 1. 5 people are not there. So you cannot proceed further. That is a problem here. You only say, right, maximum degree 6 is 2 people, then how degree 1 possible? Right, that same problem is right here it is coming. Next 5 people should be decrement by 1. I have only 4. It is not possible. So not graphic. Fine. The expected question, they will give degree sequences. They will ask you simple graph possible or not. You have to verify. Procedure is, this is the procedure, whatever I explained. This is the procedure one by one. He's saying that I am going outside. See, he's saying like this. I am going outside. My degree 5 means 5 people are adjacent to me. 5 people are adjacent to me. My degree 5. I am going outside. 5 people are adjacent. So next 5 people decrement by 1. Next 5. 1, 2, 3, 4, 5. Yeah, everyone said that yes, we can do. They done. In the next round, if you see, once again sort. So 4k. Next one is 4, right? 222 and 110. Now he's saying that I am also going outside. Next 4 people decrement by 1. Yeah, all decremented. So he became 0. Right? See the next round. So it became I think 4 ones are there. 1. Now again sort them. So 4 ones. He is saying that I am going outside. Next 1 person decrement by 1. So like that it is happening. Right? So these 2 people are over. So finally, again they will say after sorting, right? After me, next 1 person decrement by 1. So like that all zeros there. Yeah, anyone having any doubt? Preliminary checking, right? If you want to check. Maybe if you are lucky, one of the preliminary thing, whichever you knows, that one you can check, but it may take some time. Atul, there is no procedure for a preliminary checking, right? For your convenience, whatever graph theory basics you know, you can apply. No, sir, I don't want to waste time. You can go like this, right? The thing, whatever I done, it is taken care all the things. It is taken care all the things. Fine? Fine? Hello? Fine? Fine? Right. Now, can you help me now? One more small thing I want to ask you. How many vertices total? Can you help me now? How many vertices total? 6 people. Degree 6 possible. 6 people. Degree 6 possible. So that's what I'm saying. That is the meaning of basic knowledge. Instead of doing a blind procedure, use some common sense. 6 people, 1 person degree 6. How it is possible, yeah? Even though if you apply procedure, finally you will say no. But why are you applying procedure? Don't you have common basic sense? 6 people, simple graph, maximum degree possible 5 only. From where the 6 came? Directly you can say not possible. Right? That is the meaning of applying the basics. Right? Fine. Can I stop? Yeah. And one more thing, C programming, whoever not attended, right? You can attend, right? You can see the today's class. Don't postpone. Everything I will keep in the app, right? I think approximately now 6 classes are happened. Approximately now 6 classes of programming happened. Right? It came approximately, if you remove some unnecessary thing, it became 8 hours. 8 hours are approximately 9. So we are making 2 lectures, 2 to 3 lectures, 4 hours. Please read properly. Unnecessary part I will delete. I will keep in the app. Just you can revise one time. Maximum in the C programming, 10 lectures will be there. 3 to 4 hours, maybe 3 hours, maybe 4 hours. 10 lectures will be there. Watch them. If you watch them, C programming, any problem you can solve. C programming, any problem you can solve. Just watch that and PYQs you do. Just watch them and do PYQs. Okay, fine. Yeah, syllabus of DS tomorrow test. Tomorrow not DS, not. What is the tomorrow test? DS or DMS? Tomorrow DM, right? Tomorrow 8 a.m. DM. Can you revise once? See, in the DM, can I give graph theory also? In DM, can I give graph theory also? DM, can I give graph theory? Yeah, go ahead. Right, go ahead. Few questions of DM, few questions of mathematical logic, few questions of graph theory. Both I will give. Let's see who will come number one, right? Let's see top three people. Let's see top three people. Tomorrow, not tomorrow, day after tomorrow, right? Day after tomorrow, right? Not tomorrow, day after tomorrow. Sunday, DS. Sunday, DS. Total syllabus. Atul, total syllabus. DS, total syllabus. Mostly I will concentrate trees. Trees and linked list I will concentrate. Mostly I will concentrate trees and linked list. Trees and linked list I will concentrate mostly. Initial classes I concentrated the arrays and hashing and graph traversal. Now here I will concentrate mostly trees and linked list. Right? Fine. Thank you. Thanks everyone. Thanks everyone. 8 o'clock. Please start writing. Please start writing.